There it is. Okay. And guys, if you could turn on your video for me, it makes it a lot easier for me to conduct the class. I can see your bright, shining faces, and I can kind of check your progress and understanding and so forth. So it helps me if you have your video on. I appreciate it. So as we continue, last week we had our kickoff for the class, and we had begun week one. We talked about several subjects. The most important thing is to walk away with a solid project charter, right? Where we have a good problem statement. During this period of time, this metric was here, it's supposed to be there, the gap is worth this. So we've kind of worked on that, evaluated that. We also started talking about tracking your primary metric, whether it's a weekly metric or a monthly metric or even a per event metric, right? I'll be offering coaching again in a couple of weeks. I had coaching this week, had a few people sign up. That was good. And we'll be offering that again in a couple of weeks, not next week, but the week after. All right. With that said, we're going to continue with our discussions, and we're going to pick up today with a discussion of a subject called OEE, Overall Equipment Effectiveness. Sherry, this is one of those things, if I'd have known then what I know now, my whole manufacturing engineering career would have been a different situation, right? I didn't understand what I didn't understand, right? And so OEE, while it says overall equipment effectiveness, what I'd like you to recognize is this tool is not limited to manufacturing environments, nor is it limited to looking at equipment. You can apply this to individuals. You can apply it to other pieces of resources that we have, like in a hospital. This could be applied to an operating room or an MRI machine, right? In an insurance company, this can be applied to meeting rooms. This can be applied to how people are reviewing loans or reviewing payouts. I mean, we can apply this in a lot of different ways, all right? But I'm going to go through a really basic example, and I want to talk this through with you and make sure we have some basic understanding before we get into the semi-complicated subject of how it all is done, all right? Gotham, we have bought a piece of equipment. We've got this piece of equipment, and the equipment will make 1,000 units per hour. Now, I can do other examples. We could do it with an operating room. We can do it with different things. I'm just going to use this as a simple example. If I work, and I'm working a 12-hour shift, so the math's pretty easy. If I'm working a 12-hour shift, and this unit can make 1,000 units an hour, how many units should I make a shift? Anybody? 12 hours, 1,000 units an hour, 12,000 units. Everybody agree? Everybody good? All right. Routinely, I have never made more than 6,000, right? I shouldn't say I've never. On average, I'm making 6,000 per shift. You're like, I thought you could make 12,000 a shift. Exactly. All right. So without doing any other calculation, OEE at its basis can be calculated by how many units did you produce? How many units should you have produced, right? So I produced 6,000. How many should I produce? 12,000, because I work 12 hours a day, 12 hours a shift, and I should be the equipment can run 1,000 units an hour. So I made 6,000. I should have produced 12,000. What's my OEE percentage? 50%. 6,000 divided into 12,000. Everybody good? These are common numbers. We will look at resources we have in a call center. The average person can take it takes 2 minutes to do a call. They're working a 500-minute shift, so each person should be able to take 250 calls a day. Or I've got an operating room in a hospital. It takes 1 hour to do a procedure. The equipment, the room is available to 12 hours a day. I should get 12 procedures per day. You guys with me in the idea? I've got a nurse, and this nurse has to visit each room 1 hour per day, right, in total. And so she should be able to take care of 12, if it's a 10-hour shift, she should be able to take care of, say, 10 rooms during that shift, right, with the time split out. And so you kind of work all that. You're like, okay, good. But we can never get a nurse to take care of more than 4 rooms. And we are never getting more than 6 procedures through our blah, 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 right? So the idea is, based on some estimate of how long it takes to do something, we estimate how many we should be able to do per day, per shift, per week, per month, whatever the number is, right? And then we look at our actual results, and there's a big discrepancy between the two. Okay. Everybody good with the idea? There are 3 things that keep me from producing what I want to produce, right? 3 things. Number 1, am I actually working a 12-hour shift? Okay. So yeah, the shift is 12 hours in duration. It starts at 6 a.m. and finishes at 6 p.m. I got a 12-hour shift. And then the next shift comes in. They come in at 6 p.m. They leave at 6 a.m. This is a very common rotating. You got 4 different shifts that are 2 on, 3 off, 4 on, 2 off, right? That sort of, you see this on a weekly basis where people are working 12-hour shifts. Everybody okay? But if the shift is from 6 a.m. to 6 p.m., what do I naturally assume about the equipment or the human or the room? I'm assuming they're running it for 12 hours. Is it possible it's not running for 12 hours? Yeah, it's quite possible. Why? Breakdowns, don't have material, changing the room over from one patient to another, one procedure to another, changing the equipment over from making green ones to making red ones. I mean, who knows, right? There's lots of things that keep you from running. I mean, if the operator's got to be there, they go to lunch and break. That's going to keep them from running. You guys with me in the idea? So are you actually working for 12 hours? All right. So I'm going to switch over. I'm going to stop here and I'm going to kind of switch over and go to what I affectionately call the dot cam. I'm going to stop share here. Now, a couple of things. When I go to the dot cam, so you guys are helping me remember to record, right? So I'm recording now, so we're good. Also, when I switch over to dot cam, 2 things. I need to quit. If I share my screen and I switch over to the dot cam like this, sorry, the document camera is really small and it's hard for you to see, right? So there's 2 things I have to do, Sherry. I have to, 1, stop sharing, and then I will pin this, and it should make it much bigger and easier for you to see, right? Also, it shows up a lot better in the recording. So this is free. So you guys just help me remember that. I do tend to get carried away and start talking and forget. Yeah, I leave myself notes. I do all sorts of stuff and still forget. So anyway, you guys help me out. So in this particular example, I'm working 12-hour shift. And I should be able to make 1,000 units an hour. Therefore, I should be able to make 12,000 units per shift. Everybody good? So if I take 6,000, but I'm only ever making, the best I've ever done is made 6,000 units on a shift. I mean, I shouldn't say the best, that's the average. I'm getting 6,000 units a shift. So my average, I'm going to put X bar for average, and we'll see these statistical terms later, are 6,000. I'm going to put units per shift. So if I take 6,000 and divide it by 12,000 as a very simple calculation, my OEE is 50%. Everybody good with the idea? Right. So I'm making half what I ought to be making. Okay. There are 3 reasons why that's happening. The first is called availability. Right. I went out and I started investigating, and I'm saying, okay, we are supposed to be running a 12-hour shift. But then I found, you know what? We're losing 2 hours a shift for breaks, lunches, and meetings. So we're not even running it for 12 hours. We're only running it for 10 hours because we're losing that. You guys good? And then we lose another 1 hour due to maintenance. We have to clean the room. We have to change the equipment over. We have to fix a breakdown or whatever the issue is. And then there's another hour that we're losing. So I lost an hour, lost an hour, lost an hour. I'll lose another hour because I have no material. I don't have any raw material. I don't have a patient. I don't have something else that I need to run the equipment. So at the end of the day, I'm actually only running the equipment for 8 of the 12 hours. You guys good? So right off the bat, I have lost 4 hours of time. And this process, if I took 8 divided into 12, my availability is 66%. Everybody good so far? 66%. The second thing that hinders me from producing is something called performance. And you could call this efficiency, you could call it speed, you could call it a lot of things. I'm going to call it performance. That's the more standard term, right? The performance is basically this. If I ran it for 8 hours at 1,000 units an hour, how many units should I have produced? 8,000 units. Everybody good? But you know what? I've watched this process super careful, Andy, and I produce, and the last shift I looked at, they ran it for 8 hours. They made 7,128 units. That's how many they actually made. Now, how many should they have made? They should have made 8,000 because they ran it for 8 hours. They only made 8,000 units. If I take 7,128 and divide it into 8,000, that gives me a performance of about 89%. That is, when it's running, it's only running at 89% speed. You guys good with the idea? Now, why? I don't know, Rena. I don't know if it's because if they ran it at full speed, the machine jams and it quits making product altogether and goes into downtime. I don't know if it's because that number of 1,000 is completely made up. Maybe that's not even a real number. Maybe that's something that we got off the internet. We've never actually timed our own process. I don't know. But for some reason, I'm not hitting the speed I thought I was hitting. Everybody good? So I lost some just I wasn't even running it for 12 hours. Second, when I'm running it 12 hours, I'm not running at 1,000 units a minute. I'm running at something less than that, at 89% of that speed. Everybody good? The third thing is this thing called quality. What is the assumption about all 7,128 of those? That all of them are good, right? But what I found out, quality is actually a ratio of good units to the total units. Well, I made 7,128, but out of that, only 6,000 of them were good. What's wrong with the rest of them? I don't know. They're all defective and we have to throw them away. So if I divide that into that, now I've got 84% quality. You guys follow the idea, right? The problem is this is usually what we look at is just performance. We're like, well, they're not running it at full speed. Those people are, whatever. They're just slowing the machine down. That might be it. But there's three broad categories. Are you running it as long as you think you're running it? Are you running at the full speed you think you're running, right? Or is that full speed even real? And then third, of the units I made, how many of them are actually good, right? Because if I have to do rework, I have to go take more machine capacity to make units to replace the ones that I have to go and use, right? So basically, if you take 66 times 89 times 84, that gives you the same percentage as just taking 6,000 divided into 12. But now, Rena, we've got some diagnostics. Where's our biggest loss? We're not even running it, right? So maybe I could find somebody to come run this equipment while you're on break and lunch. If I have a backup operator or I have somebody I can borrow from another area, maybe I could get those 2 hours back just by running it 2 hours by having somebody come run it while you're gone. You guys good? And maybe I can go back and figure out, why are we doing maintenance? Is it because it's breaking down? Is it because we're not maintaining it properly? Is it because the machine goes down and it takes 45 minutes for the maintenance person just to get here and it takes them 15 minutes to fix it? Maybe we could train our own people to fix it and we wouldn't have to wait for maintenance. I don't know. That's what we're trying to figure out. Right? How in the world are we not having material? What does that even mean? Is it they're not running the stuff around with the fork truck? Is it that the patient is stuck down in the examination room and we got to get them up to the MRI and now we're waiting on them to kind of get on the gurney and be brought up? I don't know, right? And then you've got this issue. Okay, we're not even running it at full speed. Why? Is that not valid? Or is it slowed down for some reason that I'm unaware of? And then third, boy, we got a serious quality issue. 84% yield, really, of the good stuff. Something's wrong. We're not making it right the first time. All right. So that's why I kind of joked, Sherry, at the beginning. If I'd understood all of this back when I was a manufacturing engineer, back in my early 30s, man, I would have been a lot more effective at understanding how to improve processes. Because you know what I always focused on, Gotham? They just ain't running it at full speed, right? And I would start doing time studies and realize, actually, they are running pretty close to full speed, but it doesn't account for the losses. Where is it going, right? So the whole purpose, I'm going to stop share. I'll scan this during the break and give it to you if you'd like, right? But we'll actually I'll work through this example in a minute with the spreadsheet that you see. Okay. So I'm going to go back and share the OEE. I'm going to unpin and I'm going to change my camera. Okay. So OEE stands for overall equipment effectiveness. But Patrice, like I said at the beginning, this is applicable to human beings. It's applicable to capital resources like operating rooms or MRI machines, or it's applicable to practically anything that we're trying to get process out of, right? Whatever that happens to be. So we use this term overall equipment effectiveness. Just remember, it could be people or it could be other capital resources. But when we start thinking about it, what we're trying to do is use this as a mechanism to figure out, why are we not producing at the rate we ought to produce, right? Where is the time going? There are 6 major losses. Setup or changeover. When we change over, for example, if you have an operating room in a hospital and you're doing knee surgeries and now you're going to go do an appendectomy in the same operating room, right? There's a serious changeover you've got to do when you get the old patient out that just had a knee surgery in and you've knee surgery done, and you got to get now the room set up for an appendectomy. 1, you got to sterilize the room. 2, you're going to bring in all different equipment, right? And different trays and different this and different to support that type of operation as opposed to the previous operation. There's not a lot of drills that are used when you're doing an appendectomy, but there are drills doing if you're going to do a knee replacement, right? So there's tooling that has to be changed, right? Some things are the same. Then you get breakdowns. Something, you know, if the lighting goes bad in the room, we can't do the next procedure until the lighting is fixed, right? So that would be a breakdown. Same with equipment, same with people, right? Minor stoppages. We had to stop the room because we've got this minor thing we've got to get fixed. We've got this, we've got this. Reduce speed. We're not running at full speed, because if we ran at full speed, it would cause other problems, right? It may cause jams or it may cause defects. So we're running at a lower rate so we get a better, right? Then you get startup loss. There's a certain amount of loss that's associated with starting up first thing in the morning. And there's a certain amount of loss that's associated with slowing down in the afternoon to do a shift change. That might be causing our issue too. But those are the major issues on equipment. They may or may not transfer over to humans and capital resources, but the same mentalities are existing, right? When we start talking about OE, there are 3 constituent elements. First is availability. How many hours or minutes are you running it versus how many you plan to run it, right? Secondly, when it's running, is it running at what we call full speed, okay? And then third, when it is running and it's producing product, of the units it produced, how many of them are acceptable, right? So imagine you're in an OR, you've done a surgery on a patient. At the end, they count the number of swabs that they use, and they count the number of hemostats to make sure they don't sew up the patient with something inside, right? So they've already cleaned, 2 people have already left. Now they're doing their count, all right? We started with 20. We used 4. Here's 16 that haven't been used. Great. Where are the other 4? Okay, I got 3 in the trash can. Can't find the 4th. Oh, is it on the floor? Is it in the patient? If they can't find anywhere else, what do they got to do? They got to start looking inside to try to find it. You guys good with the idea? Same with hemostats. That's rework. That takes time. So the procedure was only supposed to take an hour, but it took us an hour and 15 minutes because now we couldn't find the other swab, right? So that's the sort of thing that can hurt our, and that's quality. That's a quality issue, right? Why are we not keeping up? So you can apply these ideas to anything. Okay. The basic calculation, just like I went through with you, is like, here's an 8-hour shift. We were supposed to run it for 480 minutes, 8 times 60. We only ran it for 298 minutes. Why Gotham? I don't know. That's what we got to go figure out, right? But we only used it for 290. So we lost 38% of our available time due to some reasons, right? Then performance. While we were running for 290 minutes, we should have produced so many pieces per minute. We only produced that many pieces. We should have produced 66.7 units per minute. We only produced 1,927 for that number of minutes. Basically, we ran at 97%, which isn't a big deal. Generally, if it's between 95 and 105, you're probably good. It's just minor variation. But quality of the 19,000 pieces we produced, only 18,000 were good, right? So we got a quality issue of 97. But if you look at this, Reno, where's our biggest opportunity? Is it quality? Is it performance? Or is it availability? Obviously, it's availability. Right. I mean, the percentage is a big, so we got to go. And guys, that's the purpose of OEE. There's nothing magic, Catherine, about doing the calculation. It's more that it gives us the diagnostic ability to go figure out what levers do I need to turn to make this process better, right? Is it availability? Is it downtime? Or they're not there, or they don't have material, or whatever? Or is it we're not running it at full speed because we don't have fully trained people. We have so much turnover, nobody gets here long enough to get good at doing it. By the time they get good, they leave or they get promoted. So we never have people who can actually run at what we call full speed. Or is it quality? Man, we're making so many errors. We spend more of our time fixing stuff than we do making stuff. I mean, what's the deal? Okay. So this idea, and even guys, even if this is not applicable to your project, this is still applicable in terms of a mindset to figure out why are we not producing what we need to produce? Why are we not profitable? Right. And you can start going through these same broad three categories. All right. There's a spreadsheet. I'd like you to open the spreadsheet called OEE calculation worksheet. Now, again, these were handed out at the beginning of class, and I will, as a courtesy, drop that into the chat for you. If I can get the file up. There. And I'm sorry, I'm pulling the file. It took me long. Everybody's probably got it now by now, but I'll drop it into the chat as well. There. All right. So the file, I just dropped it into the chat for you. I'm also just for the sake of discussion, I'm going to drop the exercise into the chat as well that you'll be using in a moment. Don't open it yet, but it's there for you in the chat. Okay. So I'm going to open the example, and let's just take a look at the example. All right. So I'm going to switch over to this other screen and talk it through from that perspective. All right. So first of all, does everybody's numbers match my numbers on the example? Do you have an OE of 58.9%? Everybody have the same number? I'm just making sure we're looking at the same file, because sometimes I'll modify the file and save it and then accidentally save it, and it doesn't match what I had handed out. All right, so we've got that. You will notice that you've got the gross available time. That's how many hours times, in this case, it's done in minutes. You could do it in hours. You could do it a lot of different ways, right? But in this case, we're going to do it in minutes. So we're planning on running an 8-hour shift. So we planned on running it for 480 minutes. Everybody good? We lost 30 minutes for lunch, 20 minutes for breaks. We lost 10 minutes at the start and end of the shift to do the handoff, right? We lost 62 minutes for changeover from doing one thing to doing another, right? I've seen changeovers in offices where they change over from printing just regular white paper to printing letterhead or printing checks, and they have to pull something out of the tray, take the old stuff out, put the new stuff in, and all that. Maybe that's what you're dealing with. I don't know. You got preventative maintenance. We got to lubricate stuff. We got to replace this. We got to do this. We got to do that. You get breakdowns, this is called planned maintenance. This is called unplanned maintenance. If it breaks down, you got to call a mechanic. They got to come in and fix it, right? Then you got slowdowns. Slowdowns is where we intentionally slow the equipment down to make sure that we don't get jams. If you don't catch it here, it'll show up here, right? So we'd like to be able to catch it so we can identify it up front, but sometimes you can't. And then we've got the ubiquitous other, whatever the other reason is. We're out of material. We didn't have any labor. We didn't have this. We didn't have that. Who knows, right? Maybe the electricity went out. I don't know, right? But that's other. So if you take how many minutes we actually ran it versus how many minutes we were supposed to run it, that's how you get the availability. It's just a really simple calculation. Then it goes down and says, okay, what's the performance? You could do this a lot of different ways. The way this one is set up is the minutes to produce one unit, right? How long should it take to produce one unit? Well, if you're supposed to do 1,000 an hour, take 1,000 divided into 60. You got how many minutes you're supposed to, how many minutes to produce one unit. You could do it that way too. But in this case, you're saying if we produce that many units, right, and we work that many hours times, that many minutes we worked times that time per unit should have generated a certain amount of units. That's how many we actually produce. Take that, divide it into that, you get your performance. Everybody good? And then last is how many were actually good. Take that, divide it into how many you actually produced. That gives you your quality. Right. Now, just looking at this scenario, tell me some of the opportunities you see. Do you have a significant quality issue? We're throwing away a few, maybe 400 a shift, 450 a shift or so. But that's not our biggest opportunity. Where are our bigger opportunities? What do you guys see? 60 minutes divided into 480 minutes. That's like 12.5% we're losing just on changeovers. You guys see that? And we're losing another 12.5% because the operator's not there for whatever reason. And I've got a note here. That's considered free capacity. If you can just figure out a way to get somebody to cover for that while that person is off at break and lunch, you could keep the machine running. Now, if it's a bottleneck piece of equipment, that's the thing that limits us from producing overall, then we need to fix that. But if it's not a bottleneck, we may not care, right? We're more limited by what our final bottleneck is. So I'll talk more about that when we get to value stream mapping next. This is a precursor to value stream mapping, right? And you've got an issue here with some unplanned maintenance, slowdowns and preventive maintenance and breakdowns, right? But that's the real purpose of OEE, is to become a diagnostic tool to tell us what do we need to go do to get our machine up to full productive capacity, or our human up to full productive capacity, or we're taking full advantage of our OR. We did some work. I did some work with a hospital up in Ohio, and they had like 3 or 4 ORs that they were, for whatever reason, Gotham, I don't know, they were only using it 8 hours a day. You got 24 hours a day. They were only doing procedures 8 hours a day, right? Now, some of that there were some reasons for it. Some of it didn't make any sense. But many hospitals, a big profit opportunity is elective surgery, as opposed to somebody came in, they broke their leg, you got to go in and put some pins in or whatever. That's a surgery. You're going to use your OR for that. But elective surgery is a little bit, usually more profitable, right? And you can schedule it ahead of time and take better advantage of your rooms. We found that, I mean, this is crazy, Melanie. They were spending about 30 to 60 minutes in between procedures to get the room ready for the next procedure. Well, I mean, if you're trying to do 8 procedures a day, you figure procedures an hour, and you're taking half that time just to change over from one procedure to another, that's half your capacity. So if you can figure out, and then they would have, and part of that, Patrice, was they would get the room done. They would finish the procedure. They would wheel the patient out, and it'll be 15 minutes before the people were in there getting the room ready for the next procedure. It's like, you just lost 15 minutes for nothing. And then even worse than that, they have the room ready, they have the patient in there, and the doctor's nowhere to be found. It's like, you kind of can't start without the doctor, right? They're the ones doing the procedure, right? And so you start then even getting to more detail as to why we're not running the equipment, right? Yeah, it's changeover, but there's reasons within the changeover. We had a certain amount of wait time before the people even showed up to begin the changeover, or the doctor wasn't ready, or maybe the patient wasn't prepped. And so now they got to get them in the room. They got to spend time prepping the patient that should have been done before they ever brought them in the room. You follow me in the idea? So that's kind of what we're doing. Is we're trying to figure out where our opportunities are. And it's different by industry. It's different but the idea is applicable. Okay. Everybody good with the idea? And so I'm going to switch back over then to the training slide. And I want to talk through a couple things with you. If you recall last week, when I was talking about projects, I showed you a graph that said it had define, measure, analyze, improve down one side, right? And then up top, it showed your business case, your project charter, your primary metric. And I said, all projects start the same. Last week, everybody has the same. Everybody's going to have a project charter. Everybody's going to have a primary metric. But from there, projects go, it depends on what you're working on. Are you working on cycle time? Are you working on defects? Are you working on downtime? Are you working on changeover? What are you working on, right? And you're going to have a different set of types of tools you are likely to use. So what we're doing is we're taking this broad framework of DMAIC, and then we're putting all these tools in it, but they're specialized for different things, right? And so if you're dealing just with customer complaints, or you're dealing just with a quality issue, you probably won't be doing OEE. But if you're dealing with a productivity issue and you're not getting out what you're supposed to be getting out, you need to figure out why. And this is the tool to do it. Okay. So again, this is a specialized tool that you may not be using. All right. But again, the idea, right? So continuing with this, as we look at the OEE, here's that basic example we were just looking at, right? If I know it's small, but if you're losing time because of lunch breaks and starting in the shift, that's effectively free capacity. You just got to figure out how to get coverage. Can I borrow somebody from another area where it's not a bottleneck to come help run this, or whatever the case is? Number 2, if you've got changeover issues, then we would apply rapid changeover techniques. There's a tool set called SMED, and it stands for Single Minute Exchange of Dies. It's a tool set to help you reduce changeover time, right? But switching over from making one product to making the next product, right? The third one is machine downtime issue. We would apply something called total productive maintenance. Sometimes there's maintenance that the technician or the nurse or the clerk or the operator that they could do that it doesn't require maintenance to come in. Now, there's some things that you don't want people messing with. We need to get maintenance inside to do this sort of thing. But some of that stuff, you could do simple maintenance yourself. You could lubricate things. You could replace simple parts, that sort of thing. So do we need to do that sort of thing, right? Are we even maintaining the right thing in our PM schedule? Are we doing our PMs? I don't know. All questions we would want. That's all part of TPM. Then you get into this lack of material or lack of labor. Why are we losing material? It's because of our transportation systems. Is because of the way we're scheduling and purchasing. I mean, what's causing that? So you may apply Kanban or some other methodology. Or if you got lack of labor, do we have people that are cross-trained? Do people only know one job, or are they flexible enough to flex to other jobs? Right? And that's the idea behind cross-training. Then you get down to performance. All right, if we're not running at full speed, I mean, the first thing we need to do, Catherine, is let's make sure the standard we're applying is real. Okay, and I'll talk about that more in cycle time later. But sometimes the number that we're applying, why 1,000 units an hour? I mean, Andy, that sounds like a really nice round number. Why is it not 978 units an hour or 1,014? Why is it a nice even 1,000? I'll tell you why. It's probably made up. That's why. It's probably not a real number. And so we've got to go figure out, is that a real number? It may be. I don't know. But let's verify it. And if it is a real number, why are we not running at full speed? Is it because we've got issues that if we ran at full speed, it would break things? It would tear it up. It would jam it. It would do whatever. Or is it because we've got other issues? It takes operators too long to do certain parts of the task and they can't get it ready. Things that probably should have been caught in availability, but we didn't see them. Right. So by the way, performance becomes, Rena, the catch-all. So if you've got issues that you didn't record up here, it'll fall out in performance. And I'll demonstrate that in just a moment. Right. And then, of course, if you've got quality, that's a standardized Six Sigma DMAIC type project. But hopefully what you're taking away from this is OEE is a diagnostic tool to help you to understand what to go do to improve the production of your equipment, of your OR, or of your nurses on the floor or whatever. Or just as a side note, the more walking you do, the less production you do. Right. So sometimes we've got just workplaces that are chaotic and people are walking all over the place. Just out of curiosity, anybody here ever wait tables? You ever wait tables? Right. Nobody waited tables. Man, that's how I got through school. All right. Guys, one of the things you learn in waiting tables is you never walk empty-handed. You're either taking stuff out of the kitchen or you're bringing stuff back to the dishwasher or back to the kitchen or back to wherever. But you don't walk around empty-handed. And you see it. I go see people waiting tables like, I don't know who trained them or taught them. And it's something you have to learn to do. You have to learn to do that, right? But walking wastes time. So one of the things we try to do is figure out how to get rid of walking time. And you'll see this later on in some of our other techniques. But everybody okay with the idea? So each one of these then has their methodology. And this kind of fits with that methodology I had laid out in that one metric here. Everybody's chart is the same, but then all these different type projects have different tools you're likely to apply. Okay, but the end is the same too. Everybody's got a control plan. Everybody's got an executive sign off. Okay, I'm gonna get you to do an exercise. I'm gonna break you into teams. So if you would, I gave you the file OEE exercise. Go ahead and open that up. And I'm also going to give you a screenshot here, just to make sure we are all looking with the same information. Now, some of you are following along with the some of you are following along with the material that was handed out, and that's great. But if not, I'm going to give you a screenshot of this. So there. I'm going to drop that into the chat as well. Give me just a second.
So do you want us to open the
OEE exercise? Yeah, if you go ahead and open OEE exercise. And I just dropped one more. I dropped a screenshot of that of the diagnostic that we had into the chat, so you'll have access to that. And now I'm going to go back and open the file OEE exercise, and I'm going to share that with you as well. All right. Everybody got the file open? Everybody good? All right. The instructions are this. I'd like you to go through. There are 5 cases, 5 tabs. Everybody see that? I'd like you to look at the tab. And first of all, what is the OEE? Well, in this one, it is, oddly enough, 57.7%. Then the second question I'd like to ask is, where is the biggest gap? Well, is the gap quality, performance, or availability? It's availability. Everybody see that? Within availability, where is the biggest time drop? Where's our biggest loss of time? But we're losing 60 minutes for that, but we're losing 134 minutes for that. So where's the big opportunity here? It's changeover time. Everybody see that? So if you wanted to reconcile that or correct that, what would you do? You need to go work a project to address that issue. And that's where you go back to that handout I gave here. That basically says changeover. That's a SMED project. You understand what we're doing? So there's 5 cases. What I'd like you to just go through each case, identify, first of all, what's the OEE? Second, what's the biggest problem? And third, what project type would I go work to address that? Everybody understand? Everybody go with what we're going to do. All right. So let me go here. And this is basically, that's what you're doing. What's the OE? What's the biggest opportunity? What's the project type? I will give you this screenshot as well, just for the sake of discussion. And I will drop that into the chat. And to make sure that you've got, just as a memory jogger, I think you already understand what we're going to do. All right. I'm going to break you into rooms. I've got 15 minutes. That's excessive. Let's shoot for 10. If everybody's done early, and come on back and we'll pick up. Let's see. We'll do 4 teams. That means you've got 3 people per team. Remember, you break out, get a spokesperson and get somebody who's going to make a record. It could be the same person or it could be somebody different. And we'll rotate those roles around, during that. But make sure you got a spokesperson who can answer questions when we come back. Everybody good? You understand what we're going to do? All right. So rooms are created. Rooms are open. Give it about 30 seconds. If somebody doesn't join in, I'll ping them. Sometimes people, they get called away. So whatever. But I'll see you back in 10 minutes. Give it just a moment to pop in 20 seconds or so. All right, looks like everybody's back. And I'll just call on team members as we go through. I'm going to share the first case. First case was fairly straightforward. We kind of talked about that before we began. And we noted that our OE was 57%. We saw that we had availability was by far the lowest of the three broad categories. And within availability, it looks like the biggest opportunity was changeover, which would be a SMED type project. Everybody good with that one? Pretty straightforward. All right, you got case two. Oddly enough, the exact same OEE. It's almost like, Patrice, it was planned to be that way. Right. But you got the same OE. Where's the big opportunity here? Patrice, what did you and your team say? Who was your spokesperson on
Yeah, that'll be me.
Okay, perfect. And Gotham, what was your
So the biggest opportunity for case two is improve cycle time, and takt time was the tool that we thought we would use.
Okay. And so we obviously have a performance issue. Everybody agree with that? We're losing more performance than we are. This is odd, right? This is odd. And one thing I would warn you, I mentioned it, but it's not in the training slide. On performance, you always got to make sure everything's being recorded. Because watch this. Let's say that we forgot about lunch and breaks, and I just didn't put that number in. So I'm going to delete the lunch and breaks. Watch, the OEE stays the same. You guys see the OEE is still 57.7. But what happened to the performance? It went down. Right. So it compensates. That's why we say this, if it's done in the correct fashion, it's an uncheatable metric because it's going to betray where the opportunities are. And even if you don't write the opportunity, it'll show up in performance because at the end of the day, you didn't produce as many units as you should have for that many minutes of operation. Right. And so that's one of and Gotham, I only passingly mentioned that. I didn't go into a lot of detail. It's going to fall out in performance. And so first of all, let's make sure we're not missing anything, right, that we didn't record. The second thing we want to do on performance is let's make sure the standard is valid. Okay, 1 minute per unit. Again, Sherry, that's a nice round number, 1 minute. Exactly 60 seconds, really? Right? Should it be 58.9 or 62.3 or something else? Why 1? Maybe it's true. Carlos, maybe that's a real valid number. Maybe. Or maybe it's just a number somebody went, we call it, Andy, we call it atmospheric engineering, where you pull a number out of the air and kind of put it down and hold people accountable to it, right? But if it is a valid number and we're not missing anything, then Gotham, exactly. Let's go figure out where the time is going, right? Is the workplace not laid out properly? Is it just the operator? Is it so operator dependent that their skills have not been not up to the level? One of the things that you do run into, and Catherine, we see this in dealing with humans, not everybody can do the same thing in the same way, right? If you think they can, go see karaoke sometime, and you'll find out not everybody can sing like the people who are making all the money singing, right? We can sing, just not like that, right? And hey son, karaoke sounds pretty good when you're singing it and you're listening to yourself, but if you hear recording yourself, you're like, oh. So just don't. It's like seeing yourself on video. You don't want to. You don't want to see a picture of yourself, right? Same sort of thing. So maybe they're just, for whatever reason, Gotham, they're not running at the right speed because it's human dependent and they just have, either they haven't acquired the skills or they just don't have the skills. There's a wide variety in what people can accomplish. Okay. So, but you're on the right track. Everybody good? Everybody good with the idea? All right. So make sure it's a right standard. Make sure we're not missing anything. And then we start investigating the workplace. And I'm telling you, Gotham, the more they're walking, the less they're working. Right. Walking's good for cardiovascular, but it's not really good for producing product. All right. Let's look at the third case. Okay. And so in this third case, let's see, Hassan, Catherine, and Sherry, your team. If you look at this particular example, you saw that you had an OEE of, oddly enough, 57.7. It's starting to get fishy here, Patrice. But where's the big opportunity for team Hassan, Catherine, and Sherry? Who was your spokesperson?
So it looks like it's quality there.
Yeah. So availability is actually astoundingly good. Performance is right? Good. Quality, man, we're throwing away a third of what we make. We got to figure that out. What type of project would that be?
Maybe a Six Sigma?
Yeah, it would be a standardized Six Sigma defect reduction type project. Let's go, let's process map, let's brainstorm, let's do a 5 whys, let's start ferreting out what the possible problems are. Everybody good with the idea? So as we go through this, guys, remember, the purpose of OEE is to be a diagnostic tool to help you understand what do I need to do to go increase productivity, right? And so again, it's dependent on what in the first example, we were just losing a lot of time across the board. In the second example, it was definitely performance was down. Here, it's a quality issue, right? How about case 4? Nalali, Natalia, and Pamaya. Who is your spokesperson here in case 4? And if you're speaking, you're muted.
I think me.
Okay, perfect. Nalali, where is the big opportunity here?
Okay, number 4 is availability.
Yep, you got availability is the worst. And within the availability, where's the big opportunity?
TPM.
Yeah, there's something, breakdowns. We got a lot of breakdowns and a lot of slowdowns. Something's going on. And it may be these slowdowns are to help prevent the breakdowns, right? And so we got to go apply TPM. We got to figure out where the time's going, what maintenance we're doing. You know what? And this is just a side note for those of you that are familiar with maintaining equipment or that. We often get preventative maintenance schedules from the supplier of the equipment. And they tell you need to do this and do this and do this. But guys, that's their best guess based on when they sold the equipment. Sometimes they haven't updated that since they started making this stuff 20 years ago, right? We may need to adjust our PMs based on our own environment, our own, situation, the way we use the equipment, whatever. And so you may find we're maintaining things that don't need maintained, and we're not maintaining things we should be replacing on a daily basis. So that's part of TPM too, Denali. You're going to go back and start assessing. And again, we'll talk about these ideas either live or in video. All right, last situation, case 5. We look at this one and you'll notice that the OEE is actually a different number. Finally, Patrice, a different number, right? Where is the opportunity? Let's see. Andy, Mr. Thomas, and Reno, what did you guys say? Where's the big opportunity?
Yeah, so looking at this one, there's definitely opportunities in multiple places, but it seems like availability is probably where we would start with the just maintenance and machine downtime. But then we would also want to look at the average the performance. I think that all of us kind of suspected that average run rate is also kind of where is that number coming from, and then finally looking at the quality for if those two don't improve it.
Yeah, this is you ever heard of ladies' choice night or skater's choice? You can choose, but or this is like black belt's choice. Just throw a dart, you'll hit an opportunity, because an hour is about 12.5%. So you're losing an hour in lunches and breaks, and you're losing an hour in changeovers. You're losing an hour in PMs. You're losing an hour in performance, which is about 12.5%. You're losing pick. It doesn't matter. Just pick. Now, you know what will happen, Rena? People will typically pick quality because it's a double whammy. 1, you increase your capacity. 2, you save money on the scrap. So that's often in a situation like that, that's where they'll start, right? And a lot of times we get pushed to address a quality issue. And you know why? Quality is easy to identify. You made 100 of them and only 90 of them are good. What are you going to do with the other 10? We're going to throw them away. People see them going in the trash. It hits your financials. People see that right away. So a lot of times Andy, will focus on that right away because it's more obvious than, well, we're losing an hour a day in PMs. While it's just as impactful, right, this is doubly impactful because you've got the stuff being thrown away on top of that. You're losing capacity and you're throwing stuff away. Everybody good? There is no, and again, there's no right answer on this one. It's Belt's choice. Just throw a dart and pick one, right? But again, quality may be the one you hit first because it's a double whammy. All right, everybody good with OEE? What's the primary purpose of OEE? What's the goal?
Diagnostic tool.
It's a diagnostic tool to figure out where to go apply. All right. Have you ever seen, you know what an OBD is? OBD scanner for a car? Like you got problems with your car, you take it in. They have a little device they'll plug in. There's a plug underneath your steering wheel on the bottom where your knees are, right? They plug it in and it will read all the codes and all the computers, right, that are in the car. The ECU that runs the engine, the one that's running your your AC, the one that's running this and your braking system. They'll have all these computers in a car. It'll basically scan all those computers and it'll give you codes. It's a diagnostic tool. So this is an OBD scanner for processes, if you will. It's not as easy as plugging it in. You got to go get the data and do the calculations. But it does tell us where our opportunities are. And that's the purpose of it. And it tells us what tools to go apply, right, to start fixing the problem. Everybody good? So we're going to take this idea of OEE and the again, and I kind of joked about it at the very beginning, but I joked with Sherry about it. But Sherry, if I'd have understood this some 30 years ago when I was working as an engineer, manufacturing engineer, I could have had a lot better impact on the processes I was responsible for. Because even though I knew these individual elements, I had never, and it wasn't until maybe 15 years ago, about 20 years ago, I had seen all this put together in a single package. People all the time will report machine uptime, or they'll report utilization, or they'll report quality, or they'll report performance. The problem with all those disparate measures is people want to use the measure to express them in the best positive light. You with me? That is human nature, granted. Okay. So what's maintenance going to do with this stuff? You start saying, hey, we got some serious maintenance issues. Like, look, you've got a policy that says the machine has to be down 15 minutes before they can even call maintenance. You can't count that against me. So they'll want to take the 15 minutes out, right? But then if you take that 15 minutes out, the people who are performance are saying, look, we're going to do everything we can to take time, add time here so it doesn't count against my performance. Because the more time you can remove out of availability, right, the better the performance is going to look. You guys good? Let me demonstrate. If I can say, oh, but we were out of material for 30 minutes, watch what happens to the performance. All right. By the way, guys, the OEE didn't change a bit. You with me? So that's why the goal is to get this, not to express one group to be better than the, it's to diagnose genuinely, Nanali. It's to diagnose what's wrong. Where do I go apply my improvement efforts? So I get the biggest improvement for the amount of effort I have to apply. Everybody cool? And we understand that idea. That's what we're applying here. Okay, great. We're going to break now. And when we come back, I'm going to pick up with a discussion of value stream mapping. We're going to talk about value stream mapping twice. Remember, and just as a reminder, this is a combination green belt, black belt course. So the first 5 weeks, we're basically going through the green belt material and touching on subjects that sometimes are a little deeper than what some green belts see, right? So I'm touching on this is a fairly deep subject, right? But you should be familiar with it. In the 6th week, we will have 4 to 10 students join the class, right? And they are black belts. They've already been trained as a green belt. So now at that point, we're going to go back through DMAIC again. So we're going to go all the way through DMAIC in the first 5 weeks. And then the last 6 weeks, we'll go over some of the same material again. So what I'm going to do next is I'm going to introduce value stream mapping from a very high level, right? And then the second time you see it, I think week 8 or so, the second time you see it, I'll show you what I've actually been doing in practice when I consult. And there's a spreadsheet we'll use to help you diagnose. And then you can play what if scenarios. What if I improve the availability? What if I improve the quality? And you'll see how that falls out and actually makes improvement in your overall productivity. So we'll talk about that tool a little bit later on as well. Okay. But I'm going to touch on value stream mapping here at a relative cursory level, right? Kind of a high level, just to get you to understand what the concept is. And then we'll move on. So we got a couple other subjects we'll talk about today. All right. With that said, let's do our first break. And as I mentioned, Catherine, I talk really fast for a boy from South Georgia. All right. So if I Rena, people talk about learning the second language. I'm hoping to learn the first. So combine my inarticulateness with my speed of talking. It's easy to miss. So you guys feel free to interrupt or ask questions or whatever when we're going through. Fair enough? Right. And man, the more excited I get, the faster I talk. And it just gets ridiculous at some point. I sound like a guy reading off disclaimers at the end of a commercial on the radio. But nevertheless, so let's do our first break. We'll do 6 minutes. When we get back, I'm going to pick up with value stream mapping, a relatively high level view. And then we've got a couple of subjects. So I'll see you back in 6. Okay, welcome back, everyone. Before I get into value stream mapping, I want to just have a quick conversation and ask you guys a few diagnostic questions. All right. Anybody, and guys, anybody feel free to join in and throw out your ideas. What is a process? What's a process? Okay, better yet, give me an example of a process. Somebody give me an example of a process.
Like forging.
Okay, sorting, right? Sorting good stuff from bad stuff. Is that what you said, sorting?
I said forging, but sorting works.
Say it again.
I said forging, but sorting
Oh,
works.
forging. Forging is a process. All right. What are the steps in forging? You got to get the blank. You got to heat it up. You got to then either impact it with some manual or you use some sort of die where you compress it to the shape that you want, right? And you may repeat that 2 or 3 times. There may be a quench involved. There may be a lot of other steps. But yeah, forging is a process. Sorting is a process. Guys, tying your shoes is a process, right? Driving to work is a process. Getting ready to go to work is a process, okay? What is a process? A process is, generally speaking, a repetitive sequence of events that generates a desired outcome, right? So it's just a sequence of events that is, right? Is making scrambled eggs a process? Sure. Is eating a banana a process? Most people, Gotham, peel the banana before they eat it. Some people, they go crazy, right? Horses, they eat the whole thing. But most of us peel it. So there's a process to peel it. Do you peel it from the top where the stem is? Do you peel it from the bottom, right, where the old flower was? I mean, people have different processes in that. You guys good? So a process is just a repetitive sequence of events, right? What is a process map? It's a graphical representation of a process, right, which is a repetitive sequence of events. Everybody good with that idea? All right, pause. Hold that to the side. Second question. What is lead time?
The time that it takes to get everything in order for that process to run.
Okay, that could be one aspect of lead time. How about from the customer's perspective? What's lead time? Or the patient's perspective, Rena? What is lead time?
Like the time that it takes from when you put in a request for something to the time that you receive it.
Bingo. It's usually from request to receipt. Everybody good? Request to receipt. All right. Lead time to get a hip replacement. What's the lead time to get a hip replacement? You probably divide it into 2 categories. One, you've got a catastrophic injury and it has to be done right now. Or 2, it's an elective surgery. If it's let's talk about elective surgery. What's the lead time to get a hip replacement? And does it vary over time? Yeah, it varies based on demand and availability of the surgeons. Everybody good? It could be 2 weeks. It could be 6 months. It totally depends. Everybody good? But what is lead time? It's from the time you get the order, the request, the whatever it is, to when you get it satisfied. Or in manufacturing, a lot of time, lead time is from the time we get to order to the time we ship the order, right? And if you want to expedite it, we can get it to you next day. If it's going to somewhere overseas, it may take 2 weeks to get shipped there, depending on what how big it is and how you have to ship it. Everybody good with the idea? All right. Now, could you process map your process that is incorporated into the lead time? Could you map out all the steps that are required to satisfy the thing that the lead time is quoting? For example, if you wanted to get a hip replacement and you made a request, is there a process that it goes through before you can get your hip replacement? Yeah, there's a whole lot of hurry up and wait. You with me? Because you make a request, it goes to scheduling. Scheduling looks at it and makes some decisions. Say, we can get you in on October the 11th. And they bounce it off you. I can't do it on October 11th. It's my grandson's 5th birthday. I can't miss it. Okay, how about October 17th? I can do October 17th. So there's a bounce and forth like this. And then there's a whole sequence of events that has to happen after it's planned and scheduled. You've got to go get a couple more appointments so they can measure out and determine what size you're going to get and what you're going to get and blah, 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 blah. And eventually they have the surgery and then you have a hip replacement. And then there's the recuperation time and, all the things. You guys with me in the idea? when we start talking about cycle time, we always have to know when the cycle starts, when the cycle ends. In a hip replacement, when does the process end? It depends on who you're talking to. If you talk to the surgeon, when is it over with? The last stitch is put in and you're off on your way, right? And they may come in and visit with you a couple of times, but they're pretty much done. From the patient's perspective, when is it done? Is it when you're discharged? Is it when physical therapy is over? Or is it when you're back up to full capacity the way you were before you had the need for the hip replacement? Because that's the goal. It's not that you get back to where you were before the hip replacement. It's that you get back to where you were before you ever needed a hip replacement. That's allegedly the goal. All right, I've talked a lot of stuff. We're going to talk about a value stream map. All right, what is a value stream map? Just make a note to yourself. A value stream map is a data-rich, high-level process map. That's what a value stream map is, right? A value stream map, if you will, Rena, maps the lead time from the time of a request to the time the request is satisfied, either time request to ship or request to receipt. We could do it either way, right? In both of those, you have to know when the clock starts and you have to know when the clock stops, or at least what our scoping is. Where are we going to start looking at it? Where are we going to stop looking at it, right? Could you do the lead time of just the actual surgery itself? From the time the patient is taken out of their prep room to the time the patient's back in OR, right? Or you could say from the time the patient walks through the doors of the hospital to the time they walk out of the doors of the hospital. I mean, you could map it. The start and stop points are almost infinite on how many you could have. So you got to determine that too. You guys good? Now, generally speaking, it's the total lead time from request to ship or request to complete, right? But you could also map different levels of that. But in summary, what is a value stream map? It's a high-level, data-rich, that's the key, data-rich process map, right? There's a quote here, and I mentioned this in the very beginning, and I mentioned it even if you attended the overview. I mentioned this in the overview as well. The awareness session that we did. Lean is taken out of the automotive industry, right? The concepts come out of that, but we have taken those concepts and applied them. And in fact, you know what? Lean actually has its roots in the manufacture of sewing machines. Singer Sewing Machine was one of the biggest producers of product in the United States that really figured out how to mass produce things. The two big ones were Singer Sewing Machines and Colt firearms, oddly enough, right? And a lot of other people were doing these concepts, but those were the two big ones that really, and then it got into the automotive industry and they figured out building things in great big batches is not the best idea. If we can get to one piece flow, right, that's the goal. And so they started perfecting these ideas. All of these concepts in lean come from the automotive assembly plant. Once you grab a hold of that idea and you can start understanding what does one piece flow mean? What does just in time mean? What does Kanban mean? What are all these crazy terms that we use? But if you understand how they relate to that, and then Rena, here's the challenge. How do we take those ideas and apply them to our own processes? Yeah, nobody here is making cars, right? Nobody has a great big, multi-million-dollar facility with overhead conveyors that are moving things through. But we can apply those concepts to a lot of our ideas, right? Because every time if you look at a lead time, what is the thing that is being quoted? What is the thing that's being worked on? Whatever it is, what is it doing most of the time? And it doesn't matter the process. What is the thing, whether it's a request for a hip replacement, whether it's a manufacturer of a cell phone, it doesn't matter. What is the thing doing most of the time? Sitting and waiting. It is sitting and waiting most of the time. Think about when you try to get approval to travel. How long does it take to approve it? You got to go here. Here's the rationale, yes or no. It's like a 1-minute decision. Why does it take 2 weeks to get travel approved? Because what is your travel request doing most of the time? Sitting and waiting. You guys good? New vendor approval, getting an invoice approved, getting invoice paid, getting a new hire on board, credentialing, fill in the blank. What is the thing doing most of the time? Sitting and waiting. If you want to get it through the process better, faster, what do you got to do? Eliminate the sitting and waiting. You guys okay? So you got to figure out, why is it sitting and waiting? Is it running into a bottleneck? Is it because we only do that activity once every 3 months? I mean, why is it sitting and waiting? Okay. Notice the quote from Taiichi Ohno, one of the founders of Toyota Production System. Now we're back to automotive, really? But he says, all we're doing is looking at the timeline. We could read that lead time. We're looking at the timeline from the moment the customer gives us an order to the point where we collect our money, right? We are reducing the timeline by reducing the non-value added waste. What is the biggest non-value added waste in most processes? Sitting and waiting, right? Now, there's reasons it's sitting and waiting, and that's what we can't just say no more waiting. We got to figure out why it's sitting and waiting and eliminate the reason, right? Look, this is something that you learn over time, and in some of you already know this. People don't do things because they're stupid, because it's a stupid thing to do. They do it because at the time it makes sense. It seems like the right thing, right? And there's a joke, especially about teenage boys, right? The problem with bad ideas is they seem like good ideas at the time, right? And so if you ever watch Fail Army, what does good look like? Good looks like you don't break your hip. That's what good looks like. Why would you even do that thing? And people do that thing all the time. It's crazy talk, right? But there's a reason why people do things. Even if it's crazy and doesn't make sense, there's a reason why they do it. So recognize you can't just, Patrice, get rid of the waiting time. It's there for a reason. It may be a terrible reason, right? And it may not make any sense, but there's a reason why it's sitting there, right? It's a reason why we do the things we do. So we got to figure it out. You can't just eliminate the waste. You got to figure out why the waste is there. So that's what we're doing. And a value stream analysis was looking at the lead time. How do we reduce? And we could get rid of this word timeline. He said we could call it lead time, right? And you could think about a hip replacement, okay? But getting into this, how do you identify projects? Because what we're doing is you look at a value stream map. Projects are one small element of that value stream map. So you kind of got a flavor of that when we looked at OEE. You don't improve OEE. You improve the element inside of OEE that makes OEE look bad, whether it's changeover or downtime or performance or quality or whatever it is. You're looking at the sub-element. It's a diagnostic tool, right? So how do we identify a project? Well, first of all, we start with the identified project area. What are we trying to improve? What is the issue we're trying to reduce the lead time on, right? Then we build something called a value stream map, right? And I gave you the code a minute ago. What is a value stream map? It's a data-rich high-level process map. That's all it is. It's just a data-rich process map, okay? So we build two process maps, a current state, which is where we're at right now, and then we build a future state, what we would like it to look like in the future, okay? Once we build the current state and the future state, then we start identifying what are the gaps between where I'm at right now and where I want to be in the future, and how do I close that gap? I go work a project. I have to go have some input, some energy put into it, some work put into it to close that gap, right? Once I identify the gap and I identify what I'm trying to do, then I identify the proper tool set and the proper, tools that I need to go use to go fix that problem. Everybody good with the idea? All right, I'm gonna pause this for a second. And I want you to think about this. Value stream mapping is like flipping a house, right? You've watched the flipping the house shows and the twins or the husband and wife team or whoever, some celebrity, and they go in basically and they ride through a neighborhood and they see these houses are selling for $500,000 a piece. There's a house for sale for $250,000. If I buy that house and I put $150,000 in it and I can sell it for $500,000, I can make $100,000 gross margin, and then I pay. I go ahead and pay for my real estate expenses and a couple of things, and I can make a profit of 50 grand on the house. You guys good? So this is flipping a house. Basically what they do is they drive through and they try to find a house that's severely discounted because it's got issues, right? They go identify the house. They say, based on my purchase price, I can put 150 grand in it and I can then sell it for this price and be able to get my money out, all right? So they do two things. They build a current state. This is what the house looks like right now. Right. Then they build a future state. This is what I want the house to look like. Nice landscaping, all the major issues done, this fixed, that fixed, right? Catherine, it always includes busting a wall out. You always got to bust at least one wall out, because otherwise, what are the people going to do in the show? They got to have a sledgehammer, they got to kick through a wall, bust the sheetrock, whatever the case is. But they basically say, this is what it looks like now. This is what we want it to look like in the future. What are all the things we have to do? We got to replace the roof. We got to do landscaping. I got to fix the driveway. That thing is so potholed. We're just going to have to pour a new driveway, right? They're going to go inside. The kitchen's a mess. I got to fix the kitchen. I got to do this. And they basically make a list of projects, and they have contractors come in. The thing that kills me, Sherry, is they'll have the contractor come in and they're like, I want to bust out that wall right there, and I want to redo the tile in the kitchen right here, and I want to put some new countertops on, and I want 2 new chandeliers with new electrical run. How much is it going to cost? And the contractor's like, That's about $800. Like, it would cost me $800 to get the quote, much less anything else. I don't know how they get it done so cheap, but they basically are building a current state and a future state, identifying all the things they have to do to close the gap. You with me? And they got to fix the plumbing and I got to fix the electric. That's what value stream mapping is. A value stream map without a future state is practically useless, right? We have to do both states, the current state where we're at right now and the future state. Where do I want to be at some point in the future? And then how do I close the gap between the two? That's the whole point behind value stream mapping. Everybody good with the idea? All right. So what value stream mapping does is it's, if you will, I hate to say it, it is a type of diagnostic tool, just like OEE was. And in fact, it leverages our understanding of OEE to know what projects do I need to go work to close the gaps, right? So there's three forms of value stream map: current state, future state, ideal state. We don't do ideal state a lot, right? Because ideal state is like, what if we had unlimited money and unlimited time and we could fix it, right? What would it look like? Sometimes we do that as an exercise, but usually we're just doing current state and future state. And usually the future state is like 6 months from now, 3 months from now, a year from now, right? What can we reasonably do in a year's time? What's going to give us the biggest improvement for our efforts, right? Bang for the buck, if you will, right? That's what we're trying to do. So we usually just look at those two. It gives us a really good understanding of where we're at right now, right? So everybody knows this, and sometimes we kind of, make a little humor about it. But what's the first step in the Alcoholics Anonymous methodology? What's the very first step?
Admitting there's a problem.
Admit you have a problem, right? So that's the first step in the value stream map. We got to admit that the current state is not sufficient, but we've got to understand what in alcohol. There's a lot of reasons why people drink, but drinking is the problem. Right. So you got to address that first, and you got to figure out, okay, what are the underlying reasons that are causing you to do that? We can go through counseling or whatever. But the same thing with us. We got to understand we're not producing enough product. We're not meeting customer demand. We have too much scrap costs. It costs us too much money. But that's what we're doing is, okay, let's go understand what our current state is. Let's do a baseline. Okay, let's understand where our problems are. Then it also helps us establish a vision where we need to be. And then it identifies projects and tools, and it kind of breaks it all down. Okay. So let's talk about this idea of value stream mapping. The value stream map is basically our lead time. And sometimes it is literally, Rena, from order to completion. And a lot of times in manufacturing, it's from order to ship. But sometimes it's a smaller subset. The scoping is dependent on what you're trying to do. Okay. But it maps the four things that a product is doing. It's either being worked on, or it's sitting around doing nothing, or it's being moved, or it's being inspected. One of those four. Anything in a process is always doing one of those four things. It's either being worked on, whether it's value added or non-value added, somebody's doing something to it, or it's sitting around. It's raw material, it's WIP, it's finished goods. As you go to the pediatrician, we kind of talked about that last week. You go to the pediatrician, when you're sitting in the waiting room, your inventory, right? You're there for 2 hours, you get 5 minutes with the pediatrician. The rest of the time you're sitting around, right? Or you're being moved. They move you from one room to another or whatever. And then finally, you're being inspected. They're reviewing it. They're approving it. We have these different words that we'll use that really just mean inspection. Approval, review, right? Those are all audit. Those are all types of inspection that we do, right? So the other thing about value stream mapping is you've got to imagine yourself as the thing going through the process, whether it's a request for a hip replacement or whether it's a request to manufacture 200 gallons of perfume or whatever it is your process does. Imagine yourself as that thing. Sometimes that thing, Sherry, is a tangible thing that I can go it's a production order. I can move it around. I can see it as a piece of paper. Sometimes it's all digital. It's somewhere in a system somewhere. But still, that thing exists. We just have to find out where it is. Document everything that changes it. Every movement, every inspection, every whatever. All the storage locations, all the moves, everything. And what signals that? What causes us to go out and do it? All right. The information flow is something that we'll map. What tells us when to do what? How do we know what needs to happen next, right? Do we have production schedules? Do we have, schedules for the OR? Do we have, availability schedules for doctors out in the future and so forth and so on? Whatever the process is, but you want to identify what's your information flow so you know what's being communicated back and forth. And how is it communicated? Electronically, flags, semaphore? Is it a piece of paper we hand somebody, right? This is scary, all right? But this is a value stream map. One thing to take away about value stream maps is no two are alike. They always have some modifications that have to be made to accommodate the situation you're in, right? But there's several things you can pick up from the value stream map. Number one, Each one of these blocks, you guys can see my cursor. That's a step, that's a step, that's a step, 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 right? You also notice there's a triangle between every step. That triangle represents inventory, right? Inventory is just stuff that's sitting waiting for the next step. It's not, Patrice, inventory doesn't have to be what you have in the warehouse you're ready to sell. Inventory, and so kind of joke about it, but if you go to the pediatrician to take your kid to the pediatrician to see the pediatrician and you're sitting in the waiting room, you're inventory, right? From that perspective of getting through the process, you're sitting there and waiting. You guys good with the idea? So it doesn't have to be a tangible product that's sitting on the shelf waiting for somebody to buy, right? It's just things that are sitting around. That's what this is, things that are sitting around. Okay. So you've got, and you'll notice underneath every one of these blocks, there's a big box of information. Cycle time, OEE, changeovers, defect rate, how many people are working there, and so forth and so on, right? So that information is going to be dependent on whatever your process is. Above the whole thing, right, is this production planning bit. And they're basically communicating back and forth, either physically with paper or electronically with systems. You notice they may be talking to individuals, they may be talking to process steps, they may be talking to different databases that are doing different things, right? But that's that idea of the information flow. What is triggering the information flow? So you got the steps in the process, you've got inventory that's being stored, right? And again, inventory is a very loose term. It doesn't have to be a tangible thing. It could be somebody sitting in a waiting room. It could be emails sitting in your email box. It could be requests for approval. That all we're talking about is that's the sitting around time. Okay. And then you get into this information flow up top and you have all this information down below. Now, this one is showing something called Kaizen bursts. That's these little yellow boxes. They have a unique number in them, 1, 2, 3, 659, whatever the number is. And it corresponds to a list of improvements we need to go make. Right. And it's basically, one, it's things we've brainstormed that we need to do to make the process. And two, it's things that we have diagnosed through OEE or other sorts of activities where we said, we've got to fix that issue or we're not going to get our product through. There's a lot of nice to do things that we need to do. We need to sweep the floor. We need to epoxy the floor. We need to go and fix this and fix that. But if we don't fix these fundamental issues down here, it doesn't matter. We're not going to get our production out. So we got to go fix. You follow me in the idea? So we got both of those, the nice to haves, the things that need to be done and the things that must be done. So that's what this Kaizen bursts are. Is everybody okay so far? So in summary, what is a value stream map? It is a data-rich, high-level process map that basically maps your lead time from the time you get a request to the time you fulfill the request. Everybody cool? Now you'll notice this one has got pictures of trucks here. What does that mean? That stuff is being transported back and forth from your facility with little trucks, right? Or big trucks probably. And what is this one? It's a ship. You know why? Because they're doing all this work here up in New Jersey, and then they're shipping it to Costa Rica, and then they're shipping it back to New Jersey, where they then distribute it to their customer. Very common, right? Where stuff is done. Some of it's done here, some of it's done offshore, some of it's done back here, right? The good thing about this, Sherry, if it's somewhere cool about Costa Rica, you can insist, well, as a consultant, I really have to go see the process here. Then they send you off and you have to go to Costa Rica. It's really tough, but sometimes you take one for the team. You go to Costa Rica and get to see the volcanic sand. That was a cool experience, but usually it's going to New Jersey. All right. Andy, there's nothing wrong with New Jersey. Okay. It's the Garden State. We all know that, right? But in Alabama, just so you know, in Alabama, all the children are born barefoot and illiterate. Rena's going, all children are born barefoot. Wait a minute. Right. Okay. If you're going to do this, what do you need to do? Go to Gemba. Go see the process yourself. Now, obviously, I'm joking about the Costa Rica thing, but you need to go see as much of the process as you possibly can so you know what's going on. And again, you're looking at it from the perspective of the thing that's going through the process, whatever that is. You want to establish the initial steps. What are all the things that have to happen to move this from this location to this location, from order to completion, right? You can even, sometimes a lot of this is already pre-documented in routings or in other process maps that people have done, but you need to go see it yourself. Usually what is documented is not complete, doesn't show everything. You need to go and pull some more information out to make sure you understand it, right? Here is a very high level gross example, and you'll see, I'll show you a couple other examples we go through of a value stream map. So here you've got the big box store selling your product. Here you've got the raw material supplier, the steel supplier. Notice the symbols. This is a box with a little jagged thing on the top. That represents somebody external to the organization. You got production control that is communicating electronically. That's the Ziggy. It looks like a lightning bolt line, right? And production control is providing a weekly schedule and a daily schedule. A daily schedule to shipping. So in this example, Sherry, we're building the stock. We're building something and putting it in the warehouse, and then customers, we're shipping it off to them. And if we know the customer's got a big order coming up in 2 weeks, we'll build an extra bit because we know we've got to satisfy the order. But generally speaking, we're building the stock. Everybody good with the idea in this particular example, right? And then you've got the 4 main steps: cut, stamp, weld, and paint. And again, this is a grossly simple process, okay? There's standard icons we use, and you got to be careful with this. People get carried away with icons, right? And you can have icons that are so specific that unless you have a great big list of all the icons, you don't know what the icons mean. So we want to keep it relatively simple. And at least on initial process or value stream maps, it's basically process steps, outside sources, inventory, and then how you're moving stuff. There are a lot of other things we can add in, like load leveling and Kanbans and, go-see scheduling and that sort of thing. But at least the basics, the first 4 are going to be the basic steps that we do. We're trying to eliminate the waste in the process. Because remember, when we talked about the 2 broad types of projects, defect reduction type projects and cycle time reduction type projects. Cycle time reduction projects are usually trying to reduce the lead time, either from the time it hits this process step to the time it comes out of that process step. It could be that micro, or it could be for a series of 15 steps, right? How do I reduce the overall lead time? But the goal is to eliminate the waste, right? And again, I mentioned one of the biggest wastes is the waste of waiting. It's sitting around waiting for the next thing, right? And so we need to get the correct data to be able to identify these wastes. And so as you build a value stream map, remember, it's a high-level process map with data-rich, high-level process map. Cycle time changeovers, OEE. Or in fact, Patrice, if you just capture cycle time and OEE, and you've got all the data that you can go look at OEE on a separate spreadsheet, you probably got just about everything you need. With the exception of, you probably need to know how many operators there are, how many shifts you're running, so you know how much time you're producing product, right? So you'll notice same example we saw before, but now they've added a bunch of information. How often are they getting shipments from their supplier? Once a week. They're shipping out to their customer once a week. And you've got these steps: cut, stamp, weld, ship, or paint. You'll notice that there is a little picture of a human. That's like if you're looking from the top down, that's their head with their arms sticking out. Terrible picture. Some people use an oval with another oval inside, like the shoulders and the head. But in any case, the number next to it indicates how many people are doing that step. Okay. If one person can carve a small rabbit in 1 minute, then 2 people could carve 2 rabbits in 1 minute. So sometimes throwing more people in a process, as long as you got the tools, as long as you got knives and you got skilled people, you throw another person in a process, you could double your output. Or you throw 3 people at it, you could triple your output. You with me in the idea? However, if you're baking bread and you've only got 1 pan, adding another chef doesn't help your bread bake any faster, right? So some processes adding resources help. Sometimes adding extra people can slow it down because they get in each other's way. So you got to be careful with that. Sometimes if you add another workstation, you can just multiply your productivity. Not always. It depends, right? So 1 person working here, 3 people working here, 20 people working here. Now notice the cycle time, 120 seconds. But if you got 20 people working, then effectively your cycle time is 6 seconds. It still takes 120 seconds to do it, but if you got 20 people doing it, they can get 1 out every 6 seconds, or they get 20 out every 120 seconds. Same thing. You guys follow me in the idea? That's why we're looking at how many. So this is not just people, it's people in workstations, depending on how the process works. Paint, ship, and so forth. All right. When we start looking at value stream maps, we're starting to try to understand, why does it take so long? So we look at how long does it actually take, and look at the times. 5 seconds to cut it, because we're doing this stuff in mass, and you cut a whole bunch at one time, but the time for one is only 5 seconds. We stamp them, we weld them, we paint them. So you look at the time, it's like 25, 145, 225 seconds to make a unit, but it takes 36 days to get through the process. So what is the thing doing most of the time? Waiting. Exactly, Nali. Waiting. And guys, this is common across processes, right? Everything you look at, from going to the pediatrician to going to the Walmarts to a lot of things. Most of the time is sitting and waiting. So the thing is, we got to diagnose, why is it sitting and waiting, right? And you see, Rena, I worked with a company. This was actually in Ohio, a hospital group, and they were trying to reduce their malpractice insurance costs, right? They found that one of their principal costs of malpractice insurance was credentialing. You're like, wait, what? When they hire a new doctor and the doctor comes in, they got to credential the doctor. Well, it could take a long time to credential. So they'll hire doctors in before they're finished. Credentialing is making sure you actually graduated med school, you finished your internship, you don't have any outstanding malpractice insurance, you don't have, some other issues going on. They're just basically make sure that you're eligible to be a doctor. You guys saw that movie Catch Me If You Can, right? And the guy he impersonated, he was a pilot, he was a doctor, he was a college professor, he's everything, right? We're making sure that's not happening to us. But the problem is if you hire them before you're finished credentialing, you have to pay a premium on malpractice insurance. And that was what drove this whole discussion. We started mapping it out. And you start looking at credentialing, you got to call these people and you can never get them on the phone. So you got to wait for them to call you back. You're like, well, all that happening. It would take about a month to get credentialing done. Yet the average amount of time for credentialing was like 9 months. You're like, why 9 months? It's only a month's worth of work. Well, as we dug into it, we found out every doctor that was hired had to be approved by the board, right? It was part of the charter of the hospital. It was, the board only meets once a year. So it doesn't matter when you get credentialing done. They're not going to be approved until the next. And so you have to pay that. They're not fully credentialed until the board has approved them. You with me on the idea? And so as a result, they were waiting. And now if you get it the 2 months before the board meets, then the credentialing time can be less than a couple of months. But if you happen to get hired just after the board met, it'd be a whole nother year before you get credentialed, at least in terms of completing the process. So how do you solve the problem? You got to figure out why is this sitting and waiting a year or 9 months or whatever it is? This because of the policy they had. Sometimes you have just policies that drive bad behavior. Basically, they went to a monthly virtual meeting of the board where the board would get on Zoom or some such, and everybody would agree, yeah, but you know what happened, Andy? They never had a doctor they wouldn't hire. They had never rejected a doctor. If they went through all the credentialing and they were approved, the board always approved them. Then why are we waiting for the board? Well, we couldn't change that. That was a charter hospital, but we could change how frequently they met, at least virtually. So sometimes you do find, but that's what we're trying to figure out. Why is it sitting around? All right. Now, there's another reason things sit around. There's two broad reasons. Sometimes it's policy, like that bad example I gave you, Renee. That's more the exception. But sometimes you have reasons why things sit around. There's two broad reasons. One, we're batching and queuing. We do 50 of them at one time before we send them to the next step because we got a box that'll hold 50 of them and we send 50 at a time. So we wait till we get all 50 done. Or I've seen situations where, well, we do our approval meeting once every 2 weeks. And so we just have to wait till 2 weeks elapse and it's time for us to do our meeting. But sometimes you have people who work in a process says, I review all those travel requests once every Friday. I do it every Friday in the morning. That's when I do it. So if you request it on Friday afternoon, you have to wait till the next week to get approved. Sorry, that's the way I do it, right? So sometimes you have arbitrary batching and queuing like that, right? Other times you have bottlenecks, right? Which you may be feeding a process that's slower than you are, and it just has to sit and wait. You guys follow me the idea? So the two main reasons for inventory issues, other than the policy issue that we talked about, was either you're batching and queuing or you're waiting on a process that's slow. And you just have to wait for it to churn through. But sometimes it's dumb things like we only run the process once every 2 weeks. Why don't you run it every day? Because that's the way we like to do it, right? And sometimes it's completely arbitrary. Oftentimes you have people making decisions, they don't understand their impact on the process. And I got to watch my time. Anyway, there's another, I'm going to pause for a moment and I need to make sure you understand a concept. And the concept is called Little's Law. I'm not going to get into the math of Little's Law per se, but I do want to make sure you understand this concept. All right. And I got to scan that for you too. All right. Little's Law is this. It was actually identified and developed in the 1960s, and they were looking at how long it takes a CPU to process instructions. A CPU, central processing unit, is a computer chip, right? So if I put an instruction here, and we're going to use very simple terms, and it takes 1 second to process that instruction, how long will it take that instruction to get through the process? Well, that was easy enough. 1 second, right? But if I've got 5 instructions sitting here, and I add an instruction, how long is it going to take that instruction to get done? It only takes 1 second to do it, but it's going to take 6 seconds for it to get through the process. Why? It has to get in line. You guys good? Okay. So sometimes, though, we batch and queue. We don't do this process until all 5 of those are ready to go, right? So we could literally be sitting here with this thing idle, and you've got 1, 2, 3 sitting here, but we won't start this until all 5 are done. That's just the way we do our process. So as a result, how long does it take it to do? It only takes 5 seconds to do all 5, but it could take a week before you ever even start processing them, because you got to wait till 5 accumulate. But even if you're not doing that, as soon as you get 5 there, you do it, right? How long does it take to get that instruction through? It still takes 5 seconds, because it has to move in a block of 5. You with me? So even though it takes 1 second to do it, it's going to take 5 seconds, because that one takes 1 second to do, but it's going to sit over here and wait for the other 4 to get completed. You follow me in the idea, right? So I want you to look at the value stream map that's back up on the screen, and I want you to note how much inventory is between cutting and stamping. 25,000 pieces of inventory. Why? Because cutting is way faster than stamping. Look at how many pieces of inventory are between stamp and weld. Only 1,000. Why? Because stamping is the slowest step in the whole process. You with me? So they're starving the welding process, and they're getting loaded up by cutting. But here's the issue. If you've got a new order come in, and it has to get in line behind the 250,000 here and the 25,000 there, how long is it going to take to get that new order through the process? A lot of time, right? 25,000 times that cycle time. You with me on the idea? Okay. And so the more inventory you have sitting, the longer it's going to take for an item to get through the process. Everybody follow that obvious idea, right? The more stuff you got, that's why it takes so long in the pediatrician office, because there's 48 other kids that are there with their parents, and they're all coughing and hacking and sharing whatever they got with you. It's lovely, right? And then you have to sit and wait till it's eventually your turn, okay? That's what we're trying to do. So why do we try to go to one-piece flow? Because the more inventory you got set in the process, the longer it's going to take to get one through the process, right? But in the lolly, people will say, we can expedite. Okay, let's stop share for a moment. Can I move this to the front of the line? Sure, easy peasy. Just prioritize that one and do it first. And we got that one through in 1 second. Woohoo! Look at how successful you are. But what happened to the other 5? They waited an extra second, right? Did you guys see that movie, The Incredibles? You might see that movie, the cartoon characters, right? And he had Syndrome, who was trying to make all the mechanical devices so everybody could have superpowers. And he said this, very interesting. He said, why are you making all these devices? He says, because if I make devices, everybody can be a superhero. And if everybody's super, then nobody's super, right? That is, if you think about it like this, if I expedite one and get it through the process faster, can I expedite everything? Well, then you just create a new queue of things that weren't expedited and things that were. Now you got a queue of expedited things, right? And so everybody catches on to that. I want to expedite it. Everybody expedites everything. Well, if everything's expedited, nothing's expedited. You follow me in the idea? That becomes obvious. Then you have double expedite. Well, this is hot, but this is red hot. Do this one first, right? And you get these ridiculous levels of expediting. The goal is to figure out, why do we have the inventory sitting here in the first place? You guys good? That's what we've got to do. And that's what the value stream map's doing for us. It helps us identify look at the lead time here. It takes 0.003 days to do the process. It takes 36 days to get it through the process. So what's that thing doing most of the time? Just like everything else, sitting and waiting, right? The good thing about going to an amusement park on a Tuesday is that everybody else is in school or at work. So oftentimes you can go to your processes. You don't have to wait in line. The bad thing about going on a Saturday is, what are you doing most of the time? Standing in line, right? Waiting your turn, your inventory. All right. You'll notice that this is a data-rich process map. It shows how much inventory is sitting before the step, how much inventory is sitting after the step, and what the actual times are to do those things. The cycle time, the changeover, the OEE, right? And we'll talk about cycle time later. But if I take my cycle time and divide it by the OEE, that's how long it's actually going to take to get to that process. Even though when I'm working, it only takes 5 seconds. If I'm only working 80% of the time, 5 divided into 0.8, it's like going to be over 6 seconds to get it done in terms of the entire day, right? And so basically now this is showing how many days it takes to churn through that inventory based on that cycle speed, right? That cycle time. Everybody follow the idea. The more inventory you got, the longer it's going to take a unit to get through the inventory, because that's to wait in line to get up to where it's its turn. Right. So one way to get rid of that, or one way to reduce that cycle time, is get rid of the inventory. That's the question we got to ask. Remember, when you start looking at value stream maps, what is the thing doing most of the time? Waiting. So we got to diagnose why. Is it a bottleneck? Is it batch and queue? Is it some arbitrary policy? Is it some other reason? I don't know. That's what we got to figure out. So then we build the future state. Where do we want to be? There's some guidelines you can follow. There's the idea of theory of constraints. That is, you want to do everything to alleviate the bottleneck. What's the bottleneck? Imagine a 2-liter bottle of Coke, right? The bottle's this big around, the neck is that big around. You ain't getting the material out any faster than you can get it through that neck, right? So what do? One thing you do is buy a bottle with a bigger neck, then you can pour it out faster. I don't know how fast you need to get Coke out of a bottle, but that's the idea behind it, right? The smaller the bottle neck, the longer it's going to take to get all the material out of the process, right? Same sort of thing here. What is the bottleneck? Where's the thing that prohibits you from moving through the process at one-piece flow, if you will, right? So notice here, they've got some things they want to do. They want to reduce the inventory. They want to go to Kanban systems. They're going to fix some specific things with their process. They've identified 4 specific things they want to do. And there's a lot of others you could do, but just 4 here. You can see the Kaizen bursts, and they're numbered uniquely 1, 2, 3, 4, which corresponds to a list of activities. They want to reduce the changeover time from 60 minutes to 5 minutes. Okay, it's a SMED project. They want to reduce their machine downtime by getting rid of unplanned maintenance. That is, they're going to try to improve their OEE from 80 to 85% by eliminating some of that availability issue. That's a TPM type project. They want to cut their defect rate from 2.4 to 1%. That's a Six Sigma project, right? They want to reduce their inventory. That's an inventory project, probably implementing Kanban or some other methodology. Everybody good with the idea? So a value stream map is just a way to build a current state, future state, identify the gaps and what projects you need to go work. But the goal is to do as much as we can to try to eliminate the inventory. Why do we have so much inventory? Why is it all sitting around? Right. And so we're using these diagnostic tools to figure that out. Right. Word of caution. Inventory. If you guys have ever kayaked, have you ever been in a kayak before? Right. If there's been plenty of rain and the river or the creek is high, you can pretty much sit in the kayak the whole time and just scuttle on down. Right. And I'm not talking about whitewater stuff. I'm talking about, enjoying an adult beverage while you're kayaking, sort of kayaking. Right. And you don't have to get out. But if there hadn't been a lot of rain, what happens? The water level is low and all the rocks appear. And you spend a lot of time trying to get over rocks. You may even have to get out of your kayak and pull it across some certain shoals or whatever the case is. Inventory is like water in a creek. If you carry enough inventory, you don't see your problems. You don't see the rework. You don't see the scrap. You don't see the delay. You don't see the absenteeism. You don't see all that stuff. You start lowering the inventory, all this stuff starts coming to the fore and you start seeing it. It gets in the way and people get irritated about it. We can't produce, right? Lengthy setups and absenteeism and scrap and rework and all these other issues start showing up. Now, the appropriate response, Patrice, is to go address these problems. But the most common response is raise the inventory back up so we don't see them anymore, right? So just be aware, as you start lowering inventory, you start revealing problems. And you've got to address the problems. The response should not be just raise the inventory back to its previous level so it can't see them, right? What problems? I don't see anything, right? And so just be aware, you start looking at that, you're going to start showing up these issues and it can be uncomfortable, right? Here's an ER example. And in this particular ER example, we were tracking through, I think you guys call it the ED, the emergency department, that we on the East Coast often called the emergency room, ER. But you've got Patient Track, the software they were using to track patients coming in, and it helps with billing and all that other stuff. You got patients coming in from the general population in 3 general ways. They ambulate themselves, they walk in, right? Or they're brought in by ambulance, car wreck, emergency, whatever. Or some are even brought in, by helicopter. Less than 1% with helicopter. Well, we got that illustrated here too. Anyway, so you got people coming in. They come in and they get triage. Triage is an old military term for looking at people and saying, you need immediate attention, right? Or you're going to die, or you're so bad, there's nothing we can do for you, but we can, make you at least comfortable for the time being. Or you've got an injury, but it can wait. We can put a tourniquet on. We can give you a Band-Aid. We can give you some morphine. You'll be fine for a few hours. But if we don't fix this major injury here, we're going to lose the patient. So let's prioritize the ones that we can fix and not spend time on ones that won't matter and not spend ones on where they got, a splinter in their finger. Okay. That's triaging. Then, of course, you got registration. We all know about filling out the 18-page questionnaire about all your right. Then they eventually move you from the waiting room into the examination room. That's the one with the refrigerated stainless steel tables that you have to sit on, right? And then eventually the doctor comes in and does an assessment. There's a star here, Rena. And the reason the star here is because those doctors are shared resources. They do the initial assessment, they do the evaluation of any sort of testing that was done, and they may have to provide immediate care, like setting a broken arm or removing a splinter out of the eye or whatever the case is, giving you a few stitches. So they're also providing that intermediate care. Okay. So that's why that star is there. There's a shared resource. If you look at the total lead time, it's really high. And you find that the patient is doing a lot of sitting around and waiting. There's a lot of inventory in here. Right? So the team identified several things. You also notice patient tracks coordinating all these efforts. At the end, most patients get discharged. Go home, take 2 aspirin, call me in the morning. Some have intermediate care, removing a splinter, setting a broken arm, getting stitches, that sort of thing. Some are admitted, right? My mother had to go to the emergency room last week. She had heart palpitations, so they admitted her in for a couple of days for observation, right? If they're discharged, they go to the immediate population. If they're admitted, they go into the hospital. Everybody okay so far, right? We've got some lead time issues. They want this down to be significantly less, right, time. And so you'll notice this blows out and says here they've got 3 individual doctors that are on staff at any given point in time. That star is a unique, and that's why I said all these are unique. They're always something you got to modify to make it fit your current situation. But there are 3 different things they do. They do the initial assessment, they do the evaluation of any sort of testing that's done, X-rays, MRIs, whatever, and they may be providing intermediate care. They even worse, they may be sitting in their office doing paperwork, right, to record what they've been doing. So you got cycle time, changeover time, so forth and so on. Changeover time is moving from one patient to another, which includes walking, paperwork, recording, that sort of thing, right? And so we use Patrice, you notice we use the term changeover very loosely in this context. You're not changing over anything per se. It's the doctor shifting their mind to go to the next activity they have to do. And then any paperwork or anything you have to do, like that's what we consider changeover. Then we look at their availability to do those particular tasks, right? So what we did is we went back and we started making proposals. What can we do to improve the process? And we started identifying several things. You notice there's some Kaizen burst here of things that we're going to do. And this corresponds to a list of things like we combine triage with registration. So instead of having them be separate events, you couldn't be registered until you had been triaged. We just combine them in the same event, right? Which means you got to have more than one patient, more than one nurse who can do triage, right? Instead of just a dedicated triage nurse. Reduce changeover from one patient to another in registration, right? And it's because after the patient walked away, there was a whole bunch of other paperwork they had to do. How do you reduce that time? How do you reduce the MD recording time? We actually, in this example, they wind up hiring LPNs to follow the doctor around and do all the paperwork for the doctor, as opposed to the doctor having to go sit in an office somewhere and fill out all the paperwork. And then, of course, you've got the time in the lab. Can we work to reduce time in the lab? How long it takes to get a test done, whatever, if it's a blood test or whatever the case is. So there's several activities that we did in this particular example. All right. That's value stream mapping in summary. Okay. But in the takeaway, value stream mapping is mapping our lead time from the time we initiate some process to the time we complete that process, whatever that means, right? We talked about, scheduling a hip replacement. There's a time that you request it, right? Or you inquire about it to the time it's actually either scheduled or completed, or even it could be on the really far end, Rena, to when all rehabilitation efforts are done. I'm blanking on the term. What do you call it when you send them to like they move your arm up and down, they make you sit up and down, they make you do a bicycle. What's that called? Therapy. It's how long your physical therapy takes. I blanked on it, right? But you guys with me in the idea. So you're looking at the lead time between whatever your start point is and whatever your stop point is, right? And then we do this detailed process map that show us 2 things. What's our current state? What's our future state? And then we start identifying what do we need to do to close the gap, all right? Now, in a few weeks, I'll actually tell you because I forget. Yeah, in week 6, we're in week 2 right now. In week 6, we'll actually review value stream mapping again. But I'm going to share with you an Excel spreadsheet, and I'll show you some examples of what we've done with value stream mapping with clients to actually make dramatic improvements in their process. So there's a little spreadsheet that's actually included for you in the files that you can use to leverage that. All right, with that said, we're going to take a break, take our second break in the morning. When we come back, we're going to get into initial data analysis. We're going to talk about how do you take a bunch of numbers, a bunch of data, and turn it into information, right? The big difference, data is just numbers, right? Or pieces of information or facts that we know. Information is where we take that data and convert it into something we can do something with. We summarize it, we put it in a graph, we do something so that we can make sense of the data. So if you will, information from this perspective is summarized data. So how do we take a bunch of numbers and summarize them into something we can use? And we're going to talk about some graphical tools to do that. All right. So with that said, let's do our second break, 6 minutes. I'll see you when we pick up. We will talk about initial data analysis. All right, welcome back, everyone. If you could go live on your video, that'd be awesome. It helps me. We're going to pick up a discussion about initial data analysis. While we're doing that, if you would go ahead and look in your file folder, there is a tool called Graphical Tools. And what that does is it has 5 different graphical tools that we're going to be referring to in this, in class. Now, if you've got Minitab or you've got your own graphical tools or you've got Jump or you got, by all means, use what you've got. You do not have to use these. However, if you don't want to buy the additional software or you don't have the ability to buy the software, you're not allowed to use software, these tools were perfect, right, for what you need. They're enough to do what we need to do for the basic analysis. All right. And I'm going to share the tool with you real quick. Then I'll get into an explanation of them. But this file is called Graphical Tools. You'll notice it has several tabs on the bottom: histogram, box plot, scatter plot, time series plot, even data for exercise. If we have time, we'll do the exercise. Often we do not. All right. But just as a side note, I mentioned this last week. All of these spreadsheets are protected, but they are not password protected. If you want to unprotect them and do some modification, change some things, by all means, have at it, right? They are yours to use as you wish as part of the course. I would keep an original copy somewhere just in case it gets damaged beyond repair or whatever the case is. But you guys are welcome to do it. And the way you unzip it or the way you unlock it is go to Review, and you'll notice it says Unprotect Sheets. Once you unprotect sheet, you can do anything you want to with it, right? There is a lot of stuff that may be hidden in different places. You'll notice, like on the box plot over here, it's got a bunch of cells that are blackened out. You can unblacken them, you can widen them up, and you can see all the sausage making that's going on in the background, right? Have at it. It's yours to do with as you please. All right. With that said, I'm going to now pick up with this discussion of graphical tools. And I'm going to actually develop a couple of other ideas as we go into it, or before we go into it in detail. All right. And so we're going to talk about these graphical tools. But before I do that, I want to talk about data segmentation and stratification. And I'm going to introduce the idea of 2 types of data. And you need to make sure that you grasp both of these concepts. And then we'll actually get in the graphical tools. Okay. So I'm going to talk about segmentation and stratification. All right. Guys, look, everybody's got their video on. You can look around and see the people in the room. I could take this group of data, the people in the room, and I could break you out by who's wearing glasses and who's not wearing glasses. Now, I won't, Sherry, I won't qualify it by saying corrective eyewear because it may be piano glasses. You wear them just for the look, right? Or some people may be wearing contacts and we can't tell that visually, right? But I'll just say who's wearing glasses, who's not. Who has long hair, who has short hair? You know what the problem is, Gotham? What does it mean, long hair, right? Does it have to be touching the shoulder? Is your hair considered long? Well, to a new recruit into the Marines, you've got long hair. I mean, so what does long hair mean? We would have to define that. What do you do with Nalali where she's got her hair pulled up? Does that qualify? I mean, it's the same length, but it's pulled up, not touching her collar. So we'd have to have a diff. But I could redivide us by who's wearing a button-up shirt and who's wearing a pullover shirt. We could break this up by a myriad of ways. That is called segmentation. We will segment our data into different groups for the purpose of something called comparative analysis. That is to say, if I take the data, separate into groups, do I see a difference between the groups? And if I do see a difference in the groups, now I have to go diagnose that. But if I don't find there's a difference in the groups, I'm not going to carry that thought any further. Everybody okay with the idea? Okay. And so that's segmentation. Stratification is looking at data over time. And you hear them talk about strata when they start talking about geological processes or the age of trees or ice cores or that. They basically drill a core, they pull the data, they lay it out, and they say the stuff that was deepest or furthest into the tree is the oldest, and the first stuff that's outermost is the most recent stuff. And they will lay out things over time. They lay, look, there was a wet season, there was a dry season, here was a forest fire. Da, da, da. They look at that. That's stratification. So we'll talk about segmentation, stratification. Then I'm going to talk about 2 types of data: continuous data and attribute data. We'll discuss what that means. And then we'll get into graphical tools, specifically Pareto's, histograms, box plots, scatter plots, and time series plots. And we'll talk about how those work. All right. Before we start looking at our data, though, we want to start asking questions about our process. Now, I'm going to show you a quick game. It's kind of hard to show you the game without us having the same stuff. But I can take a book, and I'm just going to show you this game. I'm going to pull this book called The Checklist Manifesto. Checklist Manifesto is basically about the application of checklists in surgeries and the idea of stop work authority. That is, any nurse, any tech, any anybody applying any sort of anything in an OR has the ability to stop the procedure and ask, have you properly sanitized yourself? Have you washed your hands correctly? Have you done this? Have you done that? To help avoid sepsis, right? Help avoid hospital-acquired infections, right? But it doesn't matter. I could take this book and you give it to you. Let's say, Andy, let's say we're in the same room, and you picked a word in the book, and let's say you picked, I can't even read it, that word right there, which is hour. You see, is it out or hour? I can't see. It's out, right? It's out. Come out of my mouth, right? That's out. And I'm on page, I can't even see what page that is, 170. You guys good? Now let's pretend like Andy, I didn't know that. I could take this book, and you guys can do this too. It's a great bar trick. I could take this book, and in 21 yes or no questions, I can find that word, right? And you're like, there's no way, right? But remember, it was on, what page was it on, Andy? Do you remember? When it 171 or 172, what was it? Anybody remember?
170.
Was it 170 even?
I think so.
Okay.
So,
And pardon?
is that what it looked like? Yeah.
Yeah, we'll figure it out when we get there, right? All right. But I would basically, what you do is you take the book and you divide it in half. And I say, Andy, is your word on page 85 or higher? And he would answer either yes or no. And if he says yes, what have I done in one question? Gotten rid of half the book. You guys with me? So I'm trying to find a word in the book. It doesn't matter the book. It doesn't even matter the size of the book, right? But if I ask that question, is it on this page or higher? And he says, yes, I know it's not up here. Then what do? I'm going to do it again. I'll say, is your word on page 151 or higher? And what does Andy say? Yes. In 2 questions, I have eliminated 3/4 of the book. You guys with me in the idea? And you keep doing that. And you do it again. I say, okay, is your word on page 187 or higher? And he says, no. So I know it's in this. Now I've gotten rid of 7/8 of the book. And you just keep doing that until is it on page 169 or higher? Yes. Is it on page 177 or higher? No. Is it on page, 174 or higher? And he says, no. And so then I go, all right, is it on page 170 or lower? And he says, no. So I know it's on 171 or 172. But you said it was on 170. So he would have said yes, right? So I know it's on one of those pages. Yeah. And so then I would say, okay, is your word on page 169? He says no. Then it must be on 170. You see what I mean? So like in 10 pages, 10 questions, yes or no, I found the page. You guys follow that? And then I'd basically say, is your word above my finger? Yes or no? And if he says yes, I know the word's up here and it's not down there. And I just keep subdividing. Finally, I find the sentence and I divide the sentence and finally I come to the word. Say, is that your word? He says no, then it must be that word. You guys follow the idea? So if we all had textbooks, I could do that with a textbook. It's kind of a fun game. But guys, that's what we're trying to do here with these questions we're asking. The thing is, you got to put yourself into this mindset. Gotham, your process can answer any question you want to ask it, but it doesn't answer like Chat GPT. It's not that intelligent, but it can answer yes or no questions, right? So I could ask questions. Does it happen more often on Mondays or does it happen more often on the rest of the week? If I can get my data in the right format, I could test it and look at the incidence rate of Monday versus the rest of the week, right? I could ask the question, is it worse on floor 2 than it is on floor 1? And then I could get the data the right way. I could find out if that's the case. You guys follow the idea. So I can ask questions. And if I do find there's a difference, I'm going to investigate that further. If I find there's no difference, I will eliminate all the root causes that are associated with floor 1 versus floor 2, right? So that's the whole point behind what we're trying to do. So here's the questions. When does it happen? Where does it happen? Which ones does it happen to? And when it does happen, how bad is it? Let's talk to those through. All right. And these are generic, guys. You have to think about it in your context with your process. All right. When does it happen? Is it worse during certain parts? Is it worse in the morning than it is in the afternoon? Is it worse at night than it is during day? Is it worse on Mondays than it is the rest of the week? Is it worse in the first 3 months of the year or in the last 12 months of the year? Or is it worse in the summer and is it worse at the beginning of the shift or at the end of the shift versus the middle of the shift? Is it worse after a changeover? Is it worse after new raw material? Is it worse after a change in atmospheric conditions? Again, you ask those questions. If you can get your data in the right way, you can answer any of those questions. Like I said, it's not Chat GPT, but you can arrange the data to look at like a box plot or a Pareto chart or other sorts of things like that. But again, these are generic. You have to ask them relative to your process, right? Rena, the waiting time on Friday and Saturday nights is usually worse than the waiting time the rest of the week in an ER because of Friday and Saturday nights are usually coincidental with other recreational activities that people pursue. And then you get the, what's the old joke, Nanali? Here, hold my beer and watch this, right? If somebody says that, somebody's probably going to the ER, right? Because they're going to hurt themselves, right? Mixing alcohol with stunts is never a good idea. So again, you may find, and if that's the case, we probably staff differently on Friday and Saturday night than we do in other days of the week. And you may find issues like that in all sorts of processes, not with, emergency room, but other processes. All right. Where does it happen? Is it worse in one region of the city than another, or one region of the country or another? Is it worse in one factory than another, or one office or another, or even floors in a hospital, or wings of a hospital? Is it worse on one part of the machine than it is on another part of the machine? Is it worse on some parts versus other parts, or some where the part is located, or even the orientation? Is worse on the top than it is on the bottom? I don't know. These are generic questions that you have to answer, right? And again, you have to think it through for your individual process. Third, which ones does it happen to? It's that machine, never that machine. It's on first shifts, never on second shift. It's always these operators, never those operators, right? It's on these type of requests, never those type of requests. Again, if we subdivide our data, we can start asking questions. And if we can find a difference, here's the problem. Hey, son, it's not because it's first shift versus second shift. There's nothing magic about the shifts. It's something that's happening coincidental with the shifts, which operators are working, or what parts they're working on, whether management's there harassing them or not. I don't know what it is, right? But if you tested a difference between shifts and you didn't find any difference, you would not pursue that line of inquiry, right? But if you did find a difference, you're like, okay, why is it different? It's not just that it's because shift one, it comes first. It's not that. It's something else. But it's a way of taking all of your root causes and break them into large groups. And if you find there's no difference, then we won't pursue that line of inquiry. And some of those root causes fall out because they don't fit anything else. Everybody good with the idea? All right. The last one is, and this is a different one, is when it happens, how bad is it? Right. The problem is, if you're 1 minute late to work, or if you're 6 hours late to work, in either case, you're late, right? If you play football and you lose by 1 point or you lose by 38 points, you still get an L. You follow me in the idea? It doesn't matter, right? So the problem with that, though, is sometimes we have these binary decisions where we say it's good or it's bad, it's on, it's off, they pass or fail, they won or lost. But the severity is so small. Now, college football, they figured out a way to account for that, right? So if you lose to another ranked team, that's not as bad as losing to an unranked team. If you lose by 1 point, that's not as bad as losing by 40 points. You still lost, but it's not as big a deal if you're playing against a top 10 team and you lost by 1 point. You follow the idea. So that's the thing is, when it does happen, how bad is it? Is it really? I mean, Alabama losing to, say, who's big right now? Florida. I can't remember who number one is. Anybody remember number one in college football? Not that it matters. But if you lose by 1 point to that team, that's way different than losing to Valdosta Tech by 10 points, right? So because they're not even a ranked team. But that's the same story. Here's another one. Let's say I have two employees, Patrice. One was late 6 times last year. The other one was late 2 times last year. Which one's worse? Well, obviously the 6 lates. Until I told you, this person I hired on January 1, this person I hired on December 25th. You're like, they came to work 4 times and were late twice. That's way worse than coming to work 210 times and late 6 times. So we need to normalize our data. That's kind of what this is after. We need to normalize the data so we can do adequate comparisons. Okay. So again, these are generic. You just need to think about it in your process. Okay. And because we want to ask those questions. All right. That can only be done using logic, which means you need to have a decent understanding of your process before you get started, right? Or similar processes that you can leverage previous learnings off of, right? Now, these graphical tools that I was talking about can help us answer those questions. That's what the process is doing. That's what we ask the question, we collect the data, we turn the data into information via either graphical analysis or statistical analysis, or we apply logic. Now, one side note. Data is not just sharing a bunch of numbers in a database somewhere. That is one source of data, valid. But data is also individual observations that we make. I saw it, and this is what I saw. It's almost like if you watch a murder mystery on TV, they have all these facts they know. They say they were here, but there's no alibi. Okay, that means that their statement about where they were is questionable. They say they were there, and there were 12 people who will attest to it during the time the crime was committed. So we can pretty much rule them out. You see what I'm saying? So those are not data in terms of a bunch of numbers, but they are observations that we make. Guys, that's just as useful in some aspects as actual hard numbers. So we may want to look at those and understand, and they can help us, glean out which graphical analysis that we'll do. Okay. But before we do graphical analysis, we need to make sure we do a differentiation between types of data. There are lots of ways to break out categories of data, but we're going to break them into two very simple categories, right? Variable data and attribute data. Now, variable data is also known as continuous or quantitative data. I can actually quantify the value within certain groups, right? It's called continuous because it's on a continuum, right? I'll explain that more in a minute. Attribute data is discrete data. It falls in this bucket or it falls in that bucket. It's an apple or it's an orange. It's a banana or it's a pear. It has categories or specific characteristics that make it fall into very discrete buckets. Attribute data is qualitative data, right? And in medicine, we're dealing with qualitative data a lot. Do you feel pain? Yes or no. Did you get better? Yes or no. Are you cured? Yes or no, right? So there's a lot of these very binary decisions, right? You can't have a little bit of cancer. You either got cancer or you don't. And if you let it go, it's going to spread, right? So there's some things that are like that are qualitative. They're this or they're that. There's no in between. We can talk about severity, but you got it or you don't got it, right? Variable data, on the other hand, is things like weight, blood pressure, a red blood cell count, those sorts of things, where they can vary over time, right? So we'll often differentiate between qualitative data and quantitative data. All right, just a couple of side notes. Variable / continuous / quantitative is always more powerful than attribute data. That is, you can tell more with less of it, right? Attribute data, all right, attribute data is like flipping a coin. Could you flip a fair coin, Hassan, that has heads and tails? Could I flip that coin and randomly get 5 heads and 5 tails? Yeah, that's exactly what I expect. But by the same token, could I flip that coin 10 times and actually get 8 heads and 2 tails and no shenanigans were going on? It was just random data. Yeah, that can happen too. You guys good? And so you got to be careful with attribute data because it can give you weird results that are actually in keeping with what you. Now, I couldn't flip that coin 1,000 times and get 80% heads. If I did that, some shenanigans are going on. I got a special flip method. I'm lying to you about what I'm seeing, or the coin's weighted somehow. But with only 10 flips, randomly, you could get 8 and 2 or 2 and 8. Right? Usually it's going to fall between 7 and 3 and 3 and 7, but not always. Right? Could you, and so as we get into statistics, I'll talk about this more, Patrice, but we have to differentiate between is it possible versus is it probable? There are two different terms. Anything's possible, right? But is it probable? I mean, Gotham, is it possible I could become a professional baseball player at my age and skill level? Anything's possible. Is it likely? It's so extraordinarily unlikely. You're going to say that can't happen, right? It could happen. Follow your dreams, but you're going to be really, really disappointed because there's no way, right? So again, we got to be careful about that, possible and probable, right? And that's what statistics is all about. What's the probability? Okay, with that said, variable data describes the measure of a component, its height, its weight, its density, its length, its hardness, whatever it is, right? It's a measure of its luminosity, right? Its sound level. We can measure it as long as we have a measurement system like decibels or lumens or inches or centimeters or grams or whatever it is. It's always measured with a gauge of some description, like a ruler, caliper, micrometer, scale, whatever it is. And in variable data, decimals are meaningful. I can have something that's 2.46 inches long. I can have something that's 2.44 inches long, and I can quantify 200ths of an inch. I can actually have a feeler gauge that's 200 of an inch that I can use to measure the difference between the two things, right? So decimals are meaningful in variable data. It could be count data. We don't, not usually, but it could be, all right? Money is considered variable for two reasons. One, it's infinitely divisible. That is to say, dollars, dimes, pennies, millage rate, and so forth. And you can actually have negative dollars. I mean, Rena, not in your pocket. You can't have negative dollars in your pocket, but you can have negative dollars in your bank account. And as society, I think since the beginning of time, right, we have agreed on debt. So you can have a negative net worth. You can be worth less money, right, than you actually have because you've taken on debt. That's a great way to get things you need in the immediate term and pay for it over time, right? Pay for it with future earnings in the immediate term, right? But so we consider dollars are considered variable data. Percentages, you got to be careful with percentages. If the percentage can go below 0% or the percentage can go above 100%, it's variable data. Return on investment is a good example. You can have a negative ROI or you can have greater than 100% ROI, right? So that's percentages are tricky. If they can go below 0 or above 100, it's probably variable data, right? Attribute data, on the other hand, describes the attribute of something. It's good or it's bad. It's on or it's off. Even like plugs that go into a wall. We'll talk about them as male, female, right? But you've got this idea of, is it acceptable? Is it on time or late? It's this categories we put them into. And we'll wind up how many fall into those categories, and we'll get ratios, right? 154 passes, 22 failures. 16 on time, 15 are late, right? That sort of thing. We can have variable data that actually is measured with a gauge, but instead of recording the weight in pounds or the height in inches, we say, were they less than 5 foot or between 5 and 6 or greater than 6? We have so few categories, it becomes discrete data, right? In attribute data, we're describing its attribute, okay? If something is fast, that means something else is slow. If something is tall, something else is short. If something is on time, something else must be late. It's always a comparative thing, often with some sort of definition of how you determine which bucket it falls into. You guys okay with the idea? Right? So we've got this thing that we're dealing with, right? Attribute data cannot be partial. You can't have 2.6 children. You got 2 or you got 3, you got 7, you got none. You can't have 2.6, okay? Now, we understand what they mean. The census comes back, the average American household has 2.6 children and 3.1 TVs. Nobody's got 0.1 TV, right? But they're just using these numbers as general ideas. Just be aware that you can't actually have 0.1 TV. If you do, it's useless because it won't work, right? And percentages. On attribute data, the percentage is always between and inclusive of 0 and 100%, right? For example, let's talk about you did 100 procedures. How many of those procedures required you to do rework? What's the maximum number that would require you to do rework? 100%. What's the minimum percentage that would cause you to do rework? 0%. You can't have anything, you can't have negative rework, and you can't do more rework than the parts you worked on, right? So material utilization. How about this? Purity. We'll buy different reagents or different chemicals. It'll be 90% pure, 95% pure. What's the maximum purity theoretically? 100%. You can't have more than 100% purity, and you can't have less than 0% purity. You guys with me in the idea? So that's the thing about percentages. Just be careful with percentages, because people will get percentages and start treating them as if they're variable data. They're not. They're ratios of something else. You got to be careful with that. Everybody okay with that? Sometimes we can treat it that way. It's a binomial distribution. It has some limits. We'll address it on an as-need basis as if you need to do that. Okay. So there are 2 general rules that we will use. Variable data, variables also known as quantitative, or quantitative or continuous. All right, I've got a ruler here. What is continuous data? It's data that's on a continuum. The idea of a continuum is that your smaller values are always on the left and your larger values are always on the right. And it's a continuum that goes from smaller to larger from left to right. That's the first thing. Number 2, a continuum is infinitely divisible, right? If you look at this one, it has 380 millimeters. Well, I could have said it's 3.8 decimeters or 38 centimeters or 380 millimeters, or I could even get into like micrometers and nanometers and picometers, and they can even get smaller all the way down to like femtometers, right, which is like the length of one atom. You could get crazy like that. But the idea is if your measurement system can support it, this is infinitely divisible. Yeah, okay. So that's what we talk about when we talk about a continuum, right? You have a continuum of smaller values and it's infinitely divisible, right? Variable data is always measured with, this is a gauge, by the way. Variable data is always measured with a gauge, ruler, caliper, scale, whatever. And decimals make sense. They're meaningful. They tell us something. They're useful. Attribute data, on the other hand, is binomial. Good, bad, yes, no, on, off, pass, fail, on time, late, right? We have reasons, categories, definitions for why it falls into one category or another, and it's forced into one of two, right? Usually one of two. Now, it could be things like apple, banana, pear, or grape, right? Well, it's either banana or it ain't. And everything that's left over is either an apple or it ain't. And everything that's left over is either orange or it ain't. And then everything that's left over is grape, because that's the last one, right? Or whatever the categories were. So it's categorical data, right? But it's binomial, good, bad, yes, no. And we count how many fall in those categories and get ratios. Everybody understand the difference between two types of data? Generally speaking, right? Remember, variable data is more powerful than attribute. If we have our druthers, we'd rather have variable data. Sometimes we don't have a choice, right? But sometimes we actually have things that we measure with a gauge, but we write down pass or fail. Right. It's better off to actually get. Now, Rena, they will do things in medicine. They will measure the circumference of a baby's head. We talked about that last week, I think. And they will say what percentile they fall in for that age baby. Right. Are they in the 90th percentile, 50th percentile, whatever the case is. So they're actually converting a measurement into another measurement, which is percentiles, which is actually attribute data. But it's more useful than saying, well, congratulations, Denali, your baby's head is 19.2 centimeters. Like, what does that mean? Right now, if you said your baby is 6'2", you're like, holy cow, 6'2", because you're thinking feet and inches, right? But somebody says 19, you don't even know what that means. Is that good or bad? But then they'll say that's in the 55th percentile of all babies, which means your baby is perfectly healthy and right in the middle of where they ought to be for that growth rate. And you're like, awesome, right? So that's kind of, they will take and normalize stuff. That's okay. We just need to be aware of that, all right? Let's talk through these together, all right? Cars in a driveway, and I'll use these two rules. I don't know if you wrote those down. Variables, measure with a gauge, decimals make sense. Attribute is it's binary or binomial and you count, right? What is cars in a driveway? Variable or attribute data?
Attribute?
Yeah, it's attribute. You got two, you got one, you got seven. I mean, look, it's not really a problem in San Diego, but it's a problem in Pennsylvania where cars start rusting really bad. So you could have only 90% of the car left, but it's still a car, and you still get a ticket for having a car in your driveway that's up on blocks. You with me? Even if it's missing a couple of doors. So it's either you got one or you don't. Air pressure in a tire.
Variable.
It'd be variable. You measure it with a gauge, and you get it. Your PSI is 34.7 PSI. Okay, cool. All right. How about temperature?
Variable.
Variable. As long as we measure it with a thermometer of some description, we say your temperature is 101.5. Right now, Rena, we could say you have a high temperature. That's attribute data, right? But actually reporting the actual temperature of 101.5, that's variable data. You understand the distinction? I mean, by the same token, I could have said, hey, Sherry, your front tire looks a little low. That's attribute data, right? Variable is when we go measure. Hey, it's at 19.6 PSI. It is low, right? Why? Is it just leak out over time, or you got a nail in your tire? I don't know. Cholesterol level. You could argue that's variable data. Return on investment percentage. That's variable data. One, it's dealing with dollars. Two, it can be negative or greater than 100. But material utilization, the maximum is 100%. Used all the material you had. The minimum would be 0%. Oftentimes it's around 90 or 95, which means some of it gets discarded, right? So that would be attribute data because it's limited between 0 and 100. How about car speed? What do you guys say? Car speed. How do you measure car speed? With a speedometer. It's got meter in the name, it's probably a gauge, right? And you could actually quantify that with precise enough in decimals. You can say I was going 67.3 miles per hour. Now, if somebody leaned over and says, Patrice, you're going kind of fast, ain't you? That'd be attribute data, right? Because that's comparative by nature, right? But usually a car speed's reported, just like RPM, revolutions per minute, reported with a tachometer. Decimals make sense. Everybody good?
Mm-hmm.
All right. How about blood pressure?
Variable.
It's measured with the gauge. Decimals make sense. You could argue that's variable data, right? Subject to a lot of measurement error, by the way. You'll find out that if you measure your blood pressure on your right arm versus your left arm, it's going to be different because of proximity to the heart. Secondly, if you measure on your arm 3 times, you're probably going to get slightly different results. The more human-based it is, where they're counting it and they're trying to listen through a stethoscope and count when it starts beating and stops beating, that's going to be more susceptible to error than is a mechanical device that does it. But I found out the tighter you put the cuff on, you'll get a different result. The tighter the cuff, the lower the blood pressure. The higher, that is when you put it on initially. If you get it really on tight initially, you'll have a lower blood pressure than you put it on loosely and make it inflate up to it. It's weird. And it's something to do with the way it lets the air out and calculate. I don't know. It's weird.
So a practical limit is not really enforced. So like you can't have like megapascals and blood pressure, right? Like
if you do, you're Godzilla.
yeah.
Stomping on cities and high tension wires.
So a practical limit doesn't turn it into an attribute.
Maybe most of your variable data is got a natural limit anyway of 0, right? Minimum tire pressure is 0, right? Minimum temperature is 0. And upper limit, now depends on how close to the upper limit it is. It may be right censored or left censored data, but it would still be considered variable. But censoring is it can't go above this value for some reason, right? So again, the common cop out, Hassan, is to say it depends on the situation, but it does depend on the situation. It really gets into how many individual categories can you fit within the range of variation that you see, right? So if I'm trying to measure something that can either weigh somewhere between 190 and 191 pounds, but my measurement system only gives me in 1 pound increments, that's going to wind up being attribute data because I don't have any differentiation. But if I can measure to the nearest 1/10 of a pound, I may have 10 separate categories I can see within that range. So that gets into, is the data truly on a continuum? Higher is always, but if I can't differentiate between enough categories, we have to treat it as discrete data.
Is it safe to assume that it's more predictable if you have variable data than attribute?
Variable data is always better. You can tell more with less. You can learn more about the process with less. So like, for example, if you're measuring people's blood pressure or resting pulse rate or whatever, and if you say if you actually measure it with a gauge and you record acceptable, unacceptable, normal, not normal, that you took variable data, made it very weak. But if you actually record the resting heart rate, you can always go back and say, is it acceptable, yes or no? But it's better off to have the underlying data as opposed to just how many acceptables. Does that make sense? Variable data is always more powerful. And if we have our druthers, we'd rather have variable data. We can do a lot more with it, with less of it, by the way. Right. But attribute data is always susceptible to major fluctuations in percentages, especially with small samples. That's why we'll get into this later, but flipping a coin, for example, you flip a coin 10 times, you literally could get 80% heads or 20% heads and nothing weird is going on. That's just the nature of random data. Right. But you couldn't flip it 1,000 times and get 80% heads or 20% heads. You see how it's sensitive to the sample size. Whereas variable data, it's not that way. 10 data points is often enough to tell you what you need to know. 30 is definitely enough, unless you got some major cyclicity going on. But we'll investigate that more as time goes on. Fair enough? All right. So sometimes I want to make sure I don't give you consultant answers. I want to make sure I answer your question, but also sometimes I know we're going to discuss this in more detail. And I've got to kind of lay groundwork and build on the groundwork as time goes on, right? So I got to introduce concepts like this idea of the 2 types of data and let you gestate that for a bit. And then I'll touch on it again in a week or two. It'll make a lot more sense, right? So some of this stuff takes a bit to grasp. Some of you are already like, Patrice is like, I can't believe he's still talking about it. I'm done. Go to the next thing. I got it. Right? Otherwise, you're going, what was the difference again? So, guys, I got to bring everybody up to a certain level. Fair enough. Hey, Sauce. You good? Yeah. Okay. Speaker volume, that one depends on how it's measured. If it's too loud or not loud enough, that's discrete data. If we measured it with a decimal meter, that's definitely variable data. The dial, 0 to 10, I don't know about that one. Maybe, maybe not. It depends on how linear it is, I suppose, or semi-linear. Andy's going, what if it goes to 11? Do you know the joke? Yeah, spinal tap. All right, voltage. Voltage is a tricky one too, right? If it's 110 or 220, that's discrete data, right? So, don't go to England and plug your hair dryer in England or it's going to fry it. And once, Patrice, it's a magic thing. I don't know what they do in the factory, but once you let your magic smoke out, you can't get the magic smoke back in. They put it in at the factory, and if it leaks, right? But if you measure with a voltmeter, so it's 116.2 volts or it's 47.9 volts, that is variable data. So some of these, it depends on how it's measured, depends on what the context is, whether it fits into one or the other. Does that make sense? A lot of times on devices, they'll have a switch on the back. Are you 110 or 220? And they make it where it's flexible to be shipped anywhere in the world. You got to make it in the right position or else you can blow something off and let out the magic smoke. Food taste. What is food taste? It tastes good or it don't taste good, right? That's a binary thing. But what we will often do with food is we will try to put it on something called a Likert scale, Likert, Likert scale. And a Likert scale takes something that is binary, good, bad, yes, no, on, off, pass, fail, or like food taste, tastes good, doesn't taste. And it says, okay, on a scale of 1 to 5, how is your food? A 1 is it's so bad I wouldn't feed it to a dog, right? A 5 is it was the best thing I've ever had. A 3 is, and they try to get graduated changes. They do it with, in medicine, they do it with pain, right? For how much pain does a patient feel? And instead of do you feel pain, yes or no, they try to graduate the pain from a 0 or a 1 all the way up to a 10, right? And I've got an illustration that I took a picture just last week in the ER, but I haven't downloaded it. I'll show it to you after break just to clarify that. All right. Everybody okay with the idea? So that's a Likert scale, and you'll see that in surveys. If you've done, Rena, you're probably familiar with Press-Ganey surveys, where they will call a patient that's been to the ER, patient, inpatient, whatever, and they will ask them serious questions. For example, on a scale of 1 to 7, how well do you agree with the following statement? A 7 is you strongly agree, a 4 is you're neutral, a 1 is you strongly disagree, and then graduations to that. And I say, your primary care physician was concerned with your privacy, and they'll say, it was a 4. I really don't know, right? Or they'll say it was a 7. Yeah, they said they're pulling that curtain because of my privacy. Okay, cool, right? Or a 1. I heard them outside in the hall talking about my blood pressure in front of everybody. That really bothered me, right? So again, that's what they're doing. They're taking a yes, no, and trying to turn it into a Likert scale. Because if we can see graduated changes, we can see gradual improvement, right? And it points us in the right direction, right? Why does it matter to us? So we pick the right tool. All right, let's start talking through the tools. We're going to talk about this idea of a frequency plot. A frequency plot is where you're plotting the frequency. I hate to just juxtapose the terms, but it's where you're taking buckets. You're saying how many fall into this bucket, how many fall into that bucket. Or it could be 6 buckets for continuous data. How many fall into this bar, that bar, that bar, that bar. So that's a frequency plot, okay? A Pareto is a sorted frequency plot. That is, you're trying to find out how many fall in the biggest bucket and then the next subsequent buckets all the way down. It's based on, and it's trying to illustrate to us something called the 80-20 rule, right? The 80-20 rule is this. Think about 5th grade. 80% of the problems were caused by 20% of the kids, right? And if you think about, just some of the kids were throwing paper and chewing gum and pulling somebody's hair and that sort of thing. But if you start thinking about 80% of your revenue is caused by 20% of your part numbers, right? 80% in a hospital, 80% of your revenue is caused by 20% of the cases. There's a lot of things you do that you don't get any revenue from at all, but there's some you get very high profitability. 80% of your inventory value is caused by 20% of the SKUs. I mean, this idea is applicable in a lot of different ways. But the reason we do this is to separate the meaningful few from the meaningless many, right? We're trying to get bang for the buck. We're trying to prioritize where do we focus our improvement efforts to get the maximum return, right? So Pareto chart is basically summarizing your data by category and by count within category, and then sorting it from the most frequent to least frequent. Now I can look at this data. This is some data on something called an NCR, a non-conformance report. when something doesn't meet whatever the quality standard are, sometimes they'll fill out a report. Sometimes it's an NCMR, non-conforming material report. But they're basically saying these things failed quality because of these reasons. That's an NCR. And so we've got these NCRs. What category caused the most NCRs, or which one has the highest NCRs? You guys can look at that and kind of ferret out. Well, it's low moisture, 791. You guys see that? Okay, what's the next biggest one? You look around, you're like, okay, uneven wrap, 457. Everybody see that, right? But when we put it in a Pareto chart, we get a lot more information. Number one, you can see this is the frequency, how many complaints we had for that category. Well, that's that data right there, right? But you notice now it's actually graphed out from the most frequent down to the least frequent. And over here, so if you plug it into this, your data has to be pre-sorted. So, right, but that low material percentage, low moisture percentage, excuse me, accounted for 46.7 of all the defectives or all the NCRs. So you can see that here, 791, 46%. Uneven roll, 457, which is the bar here, accounted for 27%. Those two categories cumulatively explain 73% of the issues that we have with NCRs. Everybody good? The top three categories explain 80%. So don't spend a lot of time on marks or holes because there's so few of them and they have so, you need to focus on the ones that are causing most of the problems. That's the purpose of a Pareto chart. Now, I'm a stat guy. I love statistics. I get into regression analysis and DOE and gauge runner, all these fun things. But I'm going to tell you, this is one of the most powerful tools in the whole tool set, right? Which is counterintuitive because it's such a simple thing. It's the first one we talked about. But I will tell you, it is one of the most powerful things because what it does is it allows you to take all this data and summarize it into where is the biggest opportunity for me to go address right now, right? Now, you can take a Pareto and break it a lot of different ways. You could break it out on the number of NCRs. But the problem with the NCR, Hassan, is that could be one roll or that could be 70 rolls, right? So it doesn't tell us about the severity when it does happen. It just says how many counts there were. So you may break it out by total number of rolls rejected for that reason. Or you could break it out for what was the total cost in dollars, right? So you could take the exact same data and break it out a couple of different ways. And sometimes that's a useful technique. I taught a class this morning with a different company. They manufacture snack foods. He's got a machine that is jamming and shutting the machine down. And so he's like, okay, what do I do next? I said, you need to go get a Pareto chart of the reasons why the machine is jamming because it jams and stops. And we've got certain codes that are put into the computer, like the material didn't feed properly, or we have bad raw material, or we have the container got jammed, or the top would not screw onto the container. You got all these subcategories of why a jam occurs. And so the first thing you do is let's go figure out what is the predominant cause of jams. They already had the data. All you got to do is summarize it, create a Pareto. You guys follow the idea. And then if you find, and this is what he found, 80% of his jams were due to no product. Whoa. So what do you mean the no product? Well, technically it wasn't a jam. It was a shutdown. It was miscategorized, right? But the machine would shut down. They thought it was a jam. It wasn't a jam. It was that the machine was starved, so it turned itself off. But you know why it was starved, Patrice? Because there was a jam in the feed pipe that's dropping the product down into the hopper that puts it in. So it was a jam, just not the way the machine thinks it's a jam. The machine thinks it's a jam because things got jammed up and stopped it running because it all got, coagulated together. So again, you get into the idea of operational definition, which we'll talk about next week. But you can do a lot with a Pareto chart. Very powerful tool. What do you have to have? Data, right? So we're going to talk about data mining later on. All right. Secondly, in this particular category, which line accounted for the majority of the stoppages or the majority of the rejects or whatever this is? I think it's rejects. Which line accounted for the majority of them? Easy enough. Line 14. You guys see it? The biggest bar. What percentage of the total was because of line 14? 40%. That one line by itself counted 40% of all the stoppages. That's a good thing to know. Now, Rena, that could be because line 14 produces 40% of our product, and it's just a proportion based on. But then again, it could be that all these lines produce about the same amount of product, and line 14 just happens to be the worst, way far the worst. But then, Hassan, that could be because it's making the most difficult products. So it's not really line 14. It's the type of product I don't know. That's what we've got to ferret out. That's why we're asking these questions, right? But you'll notice in this case, the first 3 or 4 lines are accounting for the best. In fact, the first line accounts for 40. The top 2 account for 56. That's the cumulative percentage. Everybody good? Sometimes we will use something called a multiple level Pareto chart, where we do a Pareto, then we take the biggest category and do another Pareto. We take that biggest category and do another Pareto. So let's look at this one. Total wrapper NCR is low moisture. This is real data. Low moisture was the biggest category. We took just the low moisture category and broke it down by which machine was producing it. You'll notice they got machine 51, machine 268, machine 26A. That's 26B and 26A, and other, which is everybody else, right? Machine 51 accounted for 65% of all the low moisture complaints. Like, whoa, that's a pretty big deal. And then we go and look, okay, of all the SKUs they're making, that particular SKU, stock keeping units, what SKU stands for, right? It's the inventory number or the article number, or whatever, model number. But that particular SKU accounted for 92% of all the failures on machine 41, which accounted for 65% of all the failures too. What's interesting to note, if you do the math, 47 times 65 times 92, that one part number on that one machine accounts for 29% of all the NCRs in the business. You're like, whoa, if I can fix that one issue, I can cut out a third of the NCRs. That's a big deal. And that's why Paretos are so powerful, right? Because they really help you see where do you need to apply your improvement efforts. Everybody good with the idea? You can apply this to time per cycle step. You can apply this in a lot of different ways, right? But a very powerful tool. Any questions about Pareto charts? All righty. One last thing, you've got to get the data summarized and you got to sort the data before you put it in. Because the thing about and this is a good point to mention this, the Excel spreadsheets that you've got, none of them have macros. They're all built without macros. The reason is if you get macros in them, Excel won't let you open them. And some organizations, IT won't let you open files with macros in them because they can be pernicious. They can be bad, right? Bad macros, bad macro, go to bed, bad macro, right? These aren't, I have no macros. So the good thing is you don't have IT issues. The bad thing is you've got to do some things manually. So you do have to sort the data yourself. Everybody good? But just get the data. And so pivot tables become your friend too. Yes, Hassan.
So in the Pareto chart, normally you look at which of the lines it's having the most issues, right? But then once you break it down, do you also look at the other lines, or you already disqualified the rest of the lines?
No, you haven't disqualified them. It's just you're trying to get your maximum impact for your effort you're going to put forth, right? Recognize that just counting the number of NCRs may not be the same as counting the cost of the NCRs. These may be relatively easy to fix. We could just recondition them in an oven. Some of these may be impossible to fix, right? I can't fix tears or holes. I can't fix that, right? But like a tight roll or I may be able to rewind it. There's some costs. So this is just a count, but you may look at it by dollars. But like in this example here, you may go ahead and go to uneven wrap, but all we're doing is trying to break it down into subcategories. Now, by the way, hey, son, you could have broke this down by machine first, and then by SKU, and then by wrapper. I mean, by category, or you could broke it down by machine, then category, then SKU. I mean, there's no exactly right way to do it. But the thing is, we're trying to break it down to we call it the actionable level. Let's get to the level where we can do something about it. How much benefit will we get? In this case, if you can fix that one SKU, you can fix 29%. Sometimes you do find some really cool things like that in a project. Sometimes you don't. Sometimes, hey, son, you find, I got to fix 18 things if I'm going to get my metric. Sometimes you find it's only, I got to fix one thing. It's hard to say. It's really dependent on your data and your process. Is that fair? But yeah, you may look at these other ones, or you may just say, well, that's enough for me to focus on right now. I'm just going to focus on that one thing. Right. So again, this is a scoping issue. We talk. There's kind of a fun metric. It says managers think a team can do this. The team thinks they can do this. The reality is they can do that. Right. So we're trying to scope down to what we can actually do within the context of the time that we've got. Fair? Everybody okay? Yeah. All right. Histogram is also a frequency plot, but you'll notice this was counts by category. This is continuous data, right? So you'll notice it's always smaller on the left, goes to the bigger on the right. notice a Pareto chart, it's categories, machine type or category or whatever. But on a histogram, it's actual continuous data. And we're looking at, and when we look at a histogram, we're looking for three things. Where is the middle of the data? How spread out is the data? And what is the shape of the data? Okay. In this case, the middle is going to be the mode, the tallest bar. And it looks like the mode is around 108.5, right? It's as low as 71 and as high as 133. And it looks more or less like a bell-shaped curve. We'll talk more about normal distributions later. Everybody good? If you plot in specifications, so if I actually took that chart and I went and plotted in customers' expectations in terms of, it has to fit within that and that, you could look at that and say, you got a lot more issue with stuff falling below spec than you do above spec, right? So there's a lot of things we can do with this sort of thing with a histogram. And we'll touch on that more later, but make sure that you understand, the basics of what the tool is. All right. A box plot, totally different scenario, right? A box plot takes the exact, this is the box plot for that data. Well, what our box plot does is breaks our numbers into percentiles, right? So, Rena, we were talking earlier about baby's head circumference in percentile. That's what it's doing. It's taking your data and breaking it into percentiles, okay? And it gives us the median, which is also known as the 50th percentile or the second quartile cut point, right? Let's talk about how this works. If I had 100 kindergartners, right? Well, let's say I had 99 kindergartners. If I were to determine the average height of the kindergartners, what would I have to do? I'd have to measure the height of every kindergartner. So let's say I measured, Gautam, I measured the kindergartner. I wrote their height down on a Post-it note. I stuck it on their shirt. Then I went to the next kindergarten, measured their height. Okay. If I measured all 99 kindergartens, how would I get the average height? I would add up all the heights that I had, 47.6, 36.9, all the way down. Add up all the heights, and I would divide by 99. That would give me the average height. Everybody good? All right, so average is just average. Average is a mathematical average, okay? Let's say that I also wanted to look at the median. Why would I use the median? The median is for data that is not necessarily normally distributed, and it also calculates for a box plot. How would I get the median? Here's how you get the median. I take those 99 kindergartners, and I would have them stand in line from the shortest kindergartner here all the way up to the tallest kindergartner here. So I got the shortest one here and the tallest one here. Everybody good? And they're in order from shortest to tallest. And then I would count up to kid number 50. And I'd say, how tall are you? Like, I'm 36 inches tall. That means half the kids are shorter than that and half the kids are taller than that. That is the definition of the median. You sort the data from low to high and you count up to the middle data point, right? Half of them are above it, half of them are below it. Everybody good with the idea? All right, but here's the problem. Let's say I have 4 children. The average is like a seesaw. I have 4 children that weigh 50 pounds each. Everybody good? 4 children, 50 pounds each. They're on this side of the seesaw. I have 1 kid that weighs 200 pounds. They're on this side of the seesaw. The seesaw balances, right? Where does it balance? It balances at the average. What is the average? Well, if I've got 4 at 50 pounds each, that's 200 pounds. If I got 1 at 200 pounds, that's 200 pounds. 200 plus 200 is 400 pounds. 400 divided by 5 kids is 80 pounds. So where does the seesaw balance? At 80 pounds. You guys see that? How many kids do I have here? 4 that are below the average and 1 that's above the average. You see, this is skewed data, right? So what happens when we have skewed data like that? Think about salary range. Let's make believe. We all graduated from MIT. Awesome, right? It's awesome we even got in. So just getting in is a big win, right? But we got into MIT. We all graduated with our aeronautical engineering degree. I don't know. And the average starting salary is 100 grand. All right. So Mr. Thomas started off at 105. Mr. Gautam started off at 100. I started off at 95. Patrice started off at 100. Nanali got 105. Rena got 95. Andy's father happens to be the CEO of Boeing. Way to go, Andy, right? He graduated. He started off at 500 a year with a company car, access to the apartment in Manhattan, access to the company jet, but he only gets access 10 times a year. It's not like it's his jet, right? But he can go anywhere he wants in the world 10 times a year. His whole compensation package turned out to be $1 million a year. You guys good? So if there's 10 of us in class and all of us started about 100,000 a year and Andy got $1 million a year, that means the average starting salary is 190,000. And Rena and I are looking around going, nobody got 190,000. How'd that happen? It's because Andy, he blew the curve, right? He kind of just, because it's not what you know, Nanali, it's who you know, right? And his dad happens to be, right, major shareholder in CEO in Boeing. All right, but right now he's on strike, Andy. So you got nothing. You get the salary, but you can't start for 6 months. So sorry about that too. Anyway, that's the problem with averages. If the data is bell shaped, it's perfect. If it's not, the median. So the 50th percent. Okay, how would you get the 25th percentile? Remember the kindergartners? I'd count up to kid number 25, whatever their height is. That's the 25th percentile. Now think this through. If the kids were sorted from short to tall, how many, and then let's say the 25th percentile was 34 inches. How many kids are shorter than 34 inches? 25% of them. How many are taller than 34 inches? 75%. You guys good? If the median height was 38 inches, how many kids are shorter than 38? 50%. How many are taller? 50%. You guys good? So what I've done, these are called quartiles. I've broken my data into 4 quartiles: 4 quarters in a football game, 4 quarters in a basketball game, 4 quarters in a dollar. So I got the first 25% here, the second 25%, the third 25%, and the last 25%. Everybody see how to read the box plot? Right. So it does tell us these things, but you know what the real power of the box plot is? It's this right here. I compare multiple data sets against each other. That's the whole point behind the box plot. So I can very quickly look at a data set and see which one has the highest median, which is the line in the middle, which one has the lowest median, which is the line in the middle. And this also plots for us the average, which is that red cross with the connecting line. So it calculates the average as well, the mean, as well as the 50th percentile, the median, which is the line in the middle. All right, so looking at this, which data set has the highest median? Very quickly look at it and say, well, that's data set 4. That's easy. Which one has the lowest median? Well, data set 3. It's got the lowest median. You guys good? We talk about consistency, Patrice. Which one is the most consistent? That's based on, watch this, the interquartile range, which sounds really fancy, but that's just the difference between the 75th percentile and the 25th percentile. Basically, it's the height of the box. The taller the box, the more inconsistent it is. The tighter the box, the more consistent it is. So in this case, which process has the most consistent data? Data set number 2. See how it has the shortest box. Which one has the least consistent data? Either 4 or 7. You guys see that? It has the tallest box. We usually ignore the whiskers in that sort of scenario, right? So you can kind of better see the data here, and it shows us the individual box plots. The middle line is the median. The cross, the red cross, is the mean. The more normal the data, we'll talk about normality later. The more normal the data is, the closer those values will be together. Right. Here's a unique application that I just saw, and I mentioned this to you guys last week. One of the things that's exciting for me is I get to see innovative ways you guys get to synthesize new uses of these tools. What this particular belt did on his project that he just presented earlier this week, is he was looking at a 4-step process of what the average lead time was. So this total here is the total lead time, and he broke it out by the 4 steps. All right. Which step in the 4 steps takes the longest? Very easy to see. It's the dev fix, whatever dev fix is. You guys see that? Which step in the process took the least amount of time? The actual user support session, right? But those 4 add up to his total here. And you'll notice that the total sometimes can be as fast as 3 days, or it could take as long as 78 days. You guys see how to read that? It was just a clever way to apply the data to his particular situation. Like, that's really good, right? So anyway, scatter plot. Changing X, changing Y. Let's stop and take a break. We'll come back and pick up with the rest of this and do the exercise. Everybody good? Right? See you back in 6, and we'll resume.
Oh, Jim, I have a question for you.
Yes, ma'am.
I'm supposed to be turning in, we are all supposed to be turning in our charter, and you want a signature on there. My director doesn't come back until Tuesday.
That's okay. Turn in what you got. Just make sure you get them to review it before you get too far down the pipe, unless you're already confident they're going to support the project. But it's just to reaffirm the fact that it's an agreement between you and management about what you're working on, how bad it is, how much it needs to be improved.
Yeah, so one of the things we had to get a new charge number. It's a lot of work, so it takes a little bit more on our end. So they agreed. There's 3 projects to do whichever one, and I know probably about 300 hours. I wish I could do that one here with the class to have your feedback, but that'll take a lot longer than our 100 days that we have here.
Yeah.
But
well, I can help you out. How can I help you out? Maybe you might kick it off in if you wanted to, you could kick it off both projects. You kick off the other one at the same time, just report the one that you've already been reporting on, but you could introduce that one. We could talk about them simultaneously.
Yeah, that's the one that they're really wanting to. They're wanting the COO is wanting a lot of. They're putting a lot of heads on that one, and we're solving the problem, but we're not improving the process. So it's just like, okay, so
guess what's really solving the problem.
Exactly, because the root cause, right? And
yeah,
because
there's a saying, Patrice, that we use. Different isn't always better, but better is always different. So sometimes we're just making changes, but we're not making any better. We're just making changes. We got to be careful. Why don't you charter both of them? Sign up for coaching in 2 weeks, and let's look at both of those. And if you can get that chart, honestly, in a process like that, if you can get everybody to agree to the metric, agree with how do we identify and express the problem, not the root cause, just the problem. That's a huge win for people, because a lot of times there's a lot of ambiguity around what the problem actually. How do we measure and know that it's a problem? Yeah. You know what I mean? Yeah. So getting that on board, getting the right champion identified, and then if you just emulate what you're doing on the other project, that's a shorter duration.
Yeah,
because it's the same. There may not be as big of a difference between the projects. It's just complexity and size.
That's what I'm noticing. And we had a discussion. We haven't kicked off yet, but we just had a discussion. It was like, it's systemic, all 3 projects. But if we fix the one that's more people on there, we'll fix a lot more in almost like restructuring the entire department. And how people see what this division is supposed to do. So that's exactly what I'm putting on my I do a lot more P&P stuff, but this is definitely what we're going to be focusing on.
As you in a project like that, if you already kind of see you maybe need to reallocate resources or reassign roles, maybe the idea of the current state and the future state, and say, this is what it looks like now. This is what we want it to look like. Okay, what do I have to do the transition? You just don't want to change it overnight and try to work out the details what happens. You would like to be able to at least have a decent plan. We're going to transition in this so that by month 1, we've got this part done. By month 2 here, month 3 here. By month 6, we've got the whole transition done.
Yeah.
And so maybe use that idea, applicable to that. And then I'm dying to know, is that a dartboard behind you that you throw those little things on? Is that what you're trying to do? That Velcro they stick or something?
Yeah.
I first saw it, I thought it was like a shield used by a warrior, and those were tackles. What it was. And I'm trying to figure out how that fits with that funky looking globe thing you've got in the back. That thing. Is that light bulbs or those balloons? What is that?
Let me so you can see. It's my son had his birthday, so
this is at home.
So it looks
I didn't know if you guys manufactured lighting fixtures, and this was
no. At home. Garland and so we're Spider-Man kind of thing going on.
Well, it's a lot better than Barney. My kid, what was it? 3 years old, wanted a Barney birthday party, so we had a Barney birthday party. Some guy comes in a suit that kind of is purple, but it doesn't really look like Barney, but it's all you can get. It's copyright issues. I'm sure Spider-Man is a lot more fun.
Yeah, every other Friday I work from I'll try to do class here and then go in or work in the office. I just went to there. Everybody comes in. You can't do anything there. So, All right, I will chart both and
get a charter on it. We can talk about it during coaching if you like.
Yeah.
I'm
That's
happy
what I
to
was
touch
asking.
coaching.
That's what I was asking. Like, hey, we're doing coaching this week.
Why not? More the merrier. And see, I'm bound to learn something from you. That's the selfish aspect. I love doing this stuff. So
Yeah.
I'm happy to talk to you about it.
Yeah, cool. All right,
Um,
I'll sign up for coaching for the 10th of.
yeah, I'll send it out next week. I'm gonna do coaching Tuesday week. Not I'm with the client next week. After that, I'll do coaching again for these sessions.
Okay.
All right, welcome back, everybody. I hope you got a break. I was prevented from one, but nevertheless, I was wondering if you'd notice, if you'd hear that or not. All right, guys. So we were talking about graphical tools. I'm kidding. I wasn't. I was just prepping for the next module. But we've talked about graphical tools. We talked about Pareto chart, which it's odd. I suggested is one of the more powerful of all the tools that we have, which is surprising, right? And then we talked about the idea of a histogram and a box plot. I'm going to switch gears a bit and talk about something called a scatter plot. A scatter plot can be for either continuous or discrete data, but most of the time it's continuous versus continuous. You can do things like, especially in medicine, they will look at risk factors and likelihood of heart disease, likelihood of cancer, that sort of thing. So the outcome is binary, but they use continuous predictors like number of cigarettes you smoke a day or your resting heart rate or other factors that can predict the likelihood of certain diseases, right? But the thing about a scatter plot is your data has to be paired. And what is this? I could say there is a general relationship between shoe size and height. The human body is more or less proportional. It's not exact. Sometimes shorter people have bigger feet, and sometimes taller people have shorter feet. But generally speaking, the body's more or less proportional. So taller people have bigger feet than shorter people. We kind of recognize that, right? But I could not go to 5 people and say, what's your shoe size, what's your shoe size, what's your shoe size, and then ask 5 different people, what's your height, and put that data together. That's meaningless, right? The data has to be paired at the point of collection. I'd say, what's your shoe size and what's your height? What's your shoe size and what's your height? And then I could do a scatter plot. You guys understand? That seems obvious, but it gets missed sometimes. So make sure your data is paired at the time of collection. And then what you're doing is you're looking for relationships between a change in X versus a change in Y, right? The most common relationship we see is no relationship, right? Now, I'm going to suggest that you do something called the fat pencil test, right? Literally, get a pencil, graph your data in the scatter plot. So this is the x-axis, right? This is the predicting value. This is the y-axis. This is the predicted value, right? You could take the fat pencil and put it on your data and see how does the data fit. There's 2 things you would find. The pencil represents what we call the fitted line, or more commonly, the line of best fit. You know why it's called the line of best fit? It's the one that best fits that data. So if you look at this no relationship, and I'm just going to sketch a couple things up for fun, but I can look at that data, and where did that thing go? I'm not sharing a thing, am I? That's why I can't see where my annotation is. Sorry about that. You guys keep me honest. Feel free to stop me at any point. I do forget, right? But a scatter plot, you're looking at, this is the x-axis, the bottom. This is the y-axis. This is the independent variable. This is the dependent variable. It's called dependent because its value depends on that value, right? And so in this particular data set, I could start sketching out the line of best fit for that first data set here, right? And I could say, well, you could put a line there, you could put a line there, you could put a line. There's really no good way to put a line in that one, right? So imagine I'm putting the pencil on there, turning it. There's really no, there mathematically is a line of best fit, even if it's meaningless, right? But if I look at this second one, there's pretty much definitely a line of best fit that looks like that. You can see how it best fits that data. Mathematically, there's one best fit. You'll also notice that in this one, there's a line of best fit here. And there's 2 things you get out of the fat pencil. One, you can see where the line ought to go. That's the line of best fit. But the second thing you can do is you can look at the data spillage, right? What I'm saying is the more data that the pencil obscures, the stronger the relationship. The more data that spills out from under the pencil, the weaker the relationship. That's why this is a moderate and this is a strong relationship. You guys see that? Right? It's positive merely because the line is going up. It doesn't say anything about the slope of the line. It's just if as X increases, Y increases, that's a positive relationship. These are called negative relationship because as X increases, Y decreases. You guys see that? And again, you can apply the fat pencil test. Well, that fat pencil pretty much fits like that right there. You guys see that? Right? And this one fits something like that. But you'll notice in this second example, this one obscures a lot more data than this one. Thus, this is a stronger relationship. You guys see? Now, later on, we're going to talk about all the variation you see is caused by two things: the things you know about, the things you don't know about, right? What do I know about in this scenario? I know about that value as it relates to that. What I don't know about is why sometimes I got a value right there and sometimes I got a value right there for the exact same inputs. That's called unexplained variation, right? And this is genetics. Taller people have shorter feet sometimes, and sometimes shorter people have bigger feet. But generally speaking, what are you going to see? The taller the person there is, the bigger the feet there are. You guys good with the idea? And vice versa, the bigger the feet. So can height predict shoe size? Sure. Can shoe size predict height? Sure. It's not exact, but it's generally, it's kind of like this. You guys good? But you know what does predict pretty well? Foot size and shoe size. That predicts a lot better, right? People tend to wear shoes that fit their feet, right? You know, except for the vanity that occurs somewhere in the early 20s. And at some point you outgrow that and just start wearing the proper size shoes, right? All right, everybody okay so far with what a scatter plot does? So let me clear those. Sorry. Okay, so the scatter plot actually generates for you, and you'll find later on there's a file called fitted line plot, and it actually gives you all the statistics. Right now we're just looking at this, but this plots for us the line of best fit. Notice in this case we're saying, do the fluid ounces in a can of Coke predict the weight of the Coke? They say, yeah, there ought to be a one-to-one relationship. Hey, son, it's not one-to-one because of minor variations like in the weight of the can itself, right? Or the density of the Coke. We'd like to think all the cans of soda have the same amount of same amount of what is that called, syrup in it. But sometimes they may be more sweeter than the others. We definitely see that when you go to a restaurant, right? But generally speaking, as the fluid ounces increase, the weight increases. There's also some minor measurement error here, trying to read the meniscus on a graduated cylinder, for example. All right, let's just work this exercise together for time. Okay, what is being graphed? So everybody when you look at a scatter plot, number one, always pay attention to what is being graphed, right? This is the predicting value. This is the predicted value, right? So this is the independent. This is the dependent. This is the X. This is the Y, right? What is being predicted here? Miles per gallon, fuel economy. What is doing the predictor? Your speed, right? And what is the observed relationship? This relationship suggests the faster you drive, the better your gas mileage. Does that make sense? No, not anything I've ever heard, Sherry. It's always been faster you go, the worse your gas. But you've got to look at the scales, right? What is the speeds they're looking at? From 5 to 17 miles per gallon. Miles per hour. It's not very fast, right? Now, play this scenario out with me. Could you fill your car up with gas, park it in the driveway, leave it running, and eventually run out of gas? Yeah. You know what? Anything faster than sitting still gives you better gas mileage, obviously, right? At what point does it stop giving you better gas mileage? 1 mile per hour, 10 mile per hour? This seems to suggest up to 17 miles an hour. The faster you go, the better your gas mileage. So you always got to pay attention to the scales too, okay? Let's look at the next one. Here. What's being plotted in this one? Miles per hour, speed, and miles per hour. It's the exact same plot as this, but what's different between them? Look at the scales, right? So what's happening in this one? This is exactly what we expect to see. The faster you go, the worse your gas mileage. Because anytime you hear that, we're always thinking highway speeds. The first one here was not highway speeds. It was very slow speeds, right? Whereas this one is highway speeds. And Sherry, this fits what we expect. It's exactly what we think. Faster you go, worse gas mileage. Okay, cool. You're driving down the road at 70 miles an hour. Some guy in a pickup truck with enormous tires passes you doing 90. You know he's getting like 2 miles per gallon, but he's happy. So, okay, good for you. But that we recognize that, okay? So then, I'm going to clear that. What is that? Pay attention to the scales. What is this? This is actually the composite of those two graphs, right? This is the first graph right here. This is the second graph right here. What is this one? It's the in-between speeds. Catherine, there's a weird thing going on here. Depending on your situation, depending on who you're talking to, depending on their experience, you may ask three groups of people and they say, I'm telling you, dude, the faster you go, the better your gas mileage. And somebody else says, you're nuts. The faster you go, the worse your gas mileage. Then somebody else says, well, in my experience, no matter how fast you go, you get the same gas mileage. Are they all three correct under certain circumstances? Yeah, that's a bizarre thing. That's one of the things you start learning about a lot of aspects of life. People can have different experiences and have different realities, right? And it's not that they have different truths. It's just they have different experiences at different points along the curve, right? The other thing to take away and learn from this, right, is that there may be very few things are linear. We do linear maps all the time. Very few things are linear. Most things are curvilinear, right? Either they're asymptotic, that is, I can't draw it, or I'll try to draw it. Either they're like this, like a normal curve. Sometimes they're an S-shaped curve like that. Sometimes they're actually an asymptotic curve where it does that, right? And it just gets closer and closer and closer, but never gets to zero. It just depends. There is no right curve. But the interesting thing is very few things are actually curvilinear. I mean, actually straight. They may be straight within a very narrow inference space like that. That looks more or less straight. But when you consider it over a broader inference space, that is a larger set of data, you notice that it's curvilinear. Everybody good? By the way, this is kind of fun because this is actually the way cars behave. Check this out. Here's a series. These are all from the early 90s. I wish I could get more recent data, but I've never been able to find it anywhere else. All of these show the same behavior. When you start at zero and go up, the faster you go up to a point, the better gas mileage it gets. And then what does it do, Catherine? It kind of flattens out for a bit. And then what's it do? It starts drifting back down again. Some of them have some bouncing around, like this particular vehicle here. Some of them have a little bit more bouncing around. Some of them are very pronounced curvilinear. This one gets better gas mileage all the way up to about 55. And then what's it do? Drop off. It's interesting, right? But this is real data. And it's just a thing that you notice when you look at things, it's seldom a linear curve. It may be linear in a small space, but when you look at the whole thing, it's curvilinear. So always plot the data, always understand what your data is, what's going on with your data. So why aren't all these curves overlapped? Because different size cars, different size engines, and so forth, right? The last one that we've got that we'll talk about is something called a time series plot. And a time series plot is just looking at your data over time. Now, Andy, statement of the obvious. If you're going to do a time series plot, your data's got to be in time series order. Well, of course. But you know what? People will go pull data out of a warehouse, not have it in order, and they'll still create a time series plot. That's useless. The data has to be collected in time series order. Time series in the order in which it was created, time series in according to the timestamps or whatever. But this is real data. This is the average rainfall in Alabama over the last 100 years. Right? Tell me some things you note by looking at the graph. Guys, unmute. Tell me what you see. Does everybody see that? What does that seem to suggest? Over the last 100 years, what's happened to the average rainfall in Alabama? It's gone up. Right? It's just odd things happen, right? At the turn of the last century, there was a lot of citrus grown in South Alabama. It's gotten too cold and too wet. They can't do it, right? It stays too damp for too long. And so we don't grow citrus in South Alabama anymore, but it used to. It's just an interesting oddity, right? Another thing you can notice when you look at this data, every time you have a really wet year, what do you have a couple of years later? A really dry year. Couple of really wet years, a dry year. Wet year, dry year, wet year, dry. It's interesting behavior, right? The average, right, is just at the average. And if you look at this graph, there may only be like 1 or 2 points where the data point actually intersects with the average rainfall, right? So everybody talks about the law of averages. One of the law of averages is you never get the average. It's bizarre. right? You get close to it and you have a certain amount fit within ranges, but you may never actually get the average, which is just an odd thing, right? And you'll see this when you go with data. There's one thing I mentioned at the beginning of class, and I think I joked with one or two of you about it in coaching. But the thing is, the more you learn about graphics and how they can easily mislead you, the more you don't trust anything you see anymore, right? And then the more you learn about data and how it can be screened out to prove anything somebody wants, the more you don't believe anything you hear anymore. It's like, it's a bizarre thing. People can get any result they want by the way they screen the data and present the data. And sometimes it's presented misrepresented. Andy, remember that silly example we made earlier about starting salaries? What does MIT want to produce? The median starting salary or the average starting salary? They would much prefer to do the average starting salary because of your salary, it really pulled the average up. It's like, well, graduates from our school start on an average of $200,000 a year. And Patrice and I are going, who's getting 200? Nobody's. It's Andy, right? That's why I use medians instead of means. That's why they use median salary. You guys good with the idea? Median housing price, median test score, same sort of thing, right? All right. Look, tell me what's going on in this one. I've got 5 zones. I'm measuring the moisture content of a roll of paper coming off a machine. I'm measuring it in 5 zones, 1, 2, 3, 4, 5. Tell me what you notice. Number one, I'll tell you what you notice. All of them have the same average moisture content. What's the average moisture content? It's right around 15%. Everybody see it? Everybody has the same moisture content. And 4 of the zones are behaving more or less the same. They're all bouncing back and forth, all within around 15% plus or minus 1%. But what's the big exception? Zone 1. You guys see that? It's bouncing too high, bouncing too low. Something's wrong with the feedback loop on this one. I don't know what it is, right? But we need to go investigate that. You ever been in a room like a hotel room or an office room or something where it gets really, really warm in there and then the AC kicks on and it gets really, really cold and it cuts off and it gets really weird. It has huge swings. And you've been in other places where you never even can tell that the AC is running because it's always the same temperature. That's the goal, right? But sometimes you have like feedback loops that something's going on with zone 1. Everybody see that? So that's kind of the goal for these graphs is you begin to take data. And by the way, a time series plot is the beginning point for a control chart, which we'll talk about towards the end of training. All right. I'm going to not do the exercise. We're starting to push for time. So I want to get on with the last section, which is brainstorming. All right. Everybody okay so far with graphical tools? You've got the example. You've also got the file graphical tools so you can do all these graphs yourself. And like I mentioned, if you have Minitab or a stat graphics or a jump or some other mechanism you would rather report your data, have at it. You don't have to use my tools. In fact, the only tool I'm going to insist on is use my problem statement fill in the blank. That's the only thing I insist. If you got your own project charter for your business, have at it. Just for this project, for the one you're going to turn into class, make sure you use the problem statement summary. Patrice, the project you and I were talking about, I don't know what it was, but you got to be able to take whatever this big complex monster is and summarize it into a simple sentence. Because if you can't, the team's going to be doing this, bouncing off on everything. That's one in project management. It's one of the things that I've learned over time. You got to make the metric as obvious and as simple as you can, so everybody knows what we're working towards, right? Because and this is one of the things that you and I talked about. The corollary to that is different isn't always better, but better is always different. Right. So people will change things for the sake of changing things, and they're not necessarily making it better. They're just changing things. We got to be careful with that too. Right. So we want to make sure that any change we make, we're confident it's going to have effect on the metric that we're tracking. All right. Last bit. I'm going to talk about brainstorming. All right. First word of caution. Don't do this too early. Right. If you've got a really complex problem that has lots of facets to it or lots of, avenues to it, you may need to narrow down to one facet or one avenue and brainstorm on that. And then look at another facet, and then, because if you brainstorm on everything too quick, you're going to get so many ideas related to so many different problems and you can't separate the ideas out. So just be careful about doing this too quick. Make sure you have a good understanding of your problem. All right. Remember I mentioned to you earlier about the jams that they had in that project. They had the machine jams and they were looking. If they brainstorm too early, you're going to get a mixture of root causes for all the different types of jams that you've got. Right. And I mean jams as in the machine is jamming itself and stopping itself. Right. You need to narrow down to a category or type of jam and say, okay, what could cause that category or that type? And you may need to do brainstorming 2 or 3 different times on different categories. But if you do it too early, it can be more confusing than it is helpful. All right. there's another aspect of this, and I love little pithy quotes like this, but this is, guys, very important to us. It is what we think we know that often prevents us from learning, right? There is a difference between what we know and what we think we know. It has been shown, I've read reports that 95% or so of what people believe, they've never proven to themselves is true. They take it on somebody else's word. Now, that's not good or that's not bad, right? But it is interesting that we believe a lot of stuff we've never proven to ourselves. You follow me in the idea? We got to be careful with that in problem solving, right? Somebody can make statements, they can make claims, that's great. If we can't back it up with data, take it as a grain of salt. We want to prove everything with data, right? So as we get into brainstorming, people have ideas. There are a lot of ideas. For any particular problem, there are lots of ideas. For example, let's say I have habitual headaches. What causes habitual headaches? Now, if you go do some self-diagnosis on Google, it's brain tumors, right? And you're doomed and life's over. But it could be something as simple as you're under too much stress, or you're dehydrated, or, hey, son, your glasses have gotten out of prescription and your eyes are starting to hurt, and it's actually, communicating itself as a headache. It could be blood pressure. I mean, Catherine, it could be a house with low doorways. Maybe you're hitting your head all the time. Maybe that's why you have headaches, right? But just be careful about why you have headaches. People have all sorts of ideas, and some of them are good, some of them are not so good. So the purpose of brainstorming is to capture as many ideas as we can, but we're going to prove those ideas out with data, okay? Because, Andy, opinions are like noses. Everybody's got them, and most of them smell, right? So we want to be careful about just going on opinion. We want to qualify it with data. Okay, going on. Brainstorming is just this idea. It's a group problem-solving technique that involves the spontaneous contribution of ideas from all members of the group. Okay, cool. The idea has been around a long time. I mean, this goes back, if you go back and read the book of Job in the Bible, there's brainstorming in Job, right? I mean, so it's not like it was just invented. However, it has been formalized in the last century by a guy by the name of Alex Osborne. He used it in advertising, right? And he basically said, in brainstorming, we're trying to get as many ideas as we can in as short of a period of time as to either creative ideas or why we have a particular problem. He had 4 rules about brainstorming. Number 1, don't judge ideas when they're thrown out, right? Because if you judge the idea as soon as it's thrown out, people who actually may know what's going on may be reluctant to say anything because they saw you criticize that person. They ain't criticizing me in front of everybody, so I ain't saying nothing, right? And that's a lot of people anyway. They just don't want to say anything, not in public, right? So make sure you don't judge. Second, let people be crazy. Throw out wild ideas. Right? It's a lot easier to tame down a wild idea than to come in with a new idea. So, by the way, we're looking for quantity at this point, not quality, just quantity. Okay. And then feel free to take what somebody else said, modify it, and say it again. That's combination improvement, right? But here's what we're doing with brainstorming, guys. We're trying to take somebody's idea and we're trying to get it on a piece of paper so that we can put the idea up on the wall and we can evaluate the idea based on its own merit, not based on who said it. Because some people can argue an idea really well, and it's a bad idea, but they can argue it so well that you're convinced that's the right way to go. Other people may know the right way to go, but they do such a poor job arguing it that we just dismiss the idea, right? So we got to be careful with that. The second thing we have to be careful of is taking someone's idea because they have a very lofty rank in the organization and dismissing somebody else's idea because they have very low rank in the idea, a low rank in the organization, right? So we got to be careful about those. The goal is to get the idea away from the person so we can evaluate the idea based on its merit, not based on who said it or how they said it. Everybody good with the concept, right? That's what we're doing in brainstorming. Now, in brainstorming, there's a couple of different categories we're going to do. Later on in the improve phase, we're going to do creative brainstorming. How do we come up with a solution to address the root causes we've identified? But at this point, our purpose of brainstorming is knowledge extraction. We are trying to record what the team knows about the problem. You understand the distinction? So this is not really at this point, it's not really a creative exercise per se. It's more of a knowledge extraction. Notice some people will call it tribal knowledge. They'll call it organizational wisdom. They have different names for what people who work here know, right? And people who work here know things that people who don't work here don't know about what we know, right? It's just one of those things, right? Rena, I keep referring to you, but I've done a lot in healthcare. There's things that nurses and doctors know that other people in the general populace don't know, right? And that can be useful and that can be unuseful. It's interesting to note that this is bizarre. Smoking has a higher incidence rate among the medical field than it does in most other fields, which is completely antithetical to what you would think, because people working in healthcare see the results of smoking, but they're also under enormous sources of stress and duress. And so it's a coping mechanism. It's just interesting, right? So just sometimes things don't make sense the way they make sense, right? Just be aware that as we brainstorm, we're trying to get the current state of the problem, a list of potential root causes based on what the team already knows. Now, this has a lot of other side benefits. You give the team members a mechanism to collaborate and contribute what they know about the process. Second, they start buying into this improvement process because their ideas were heard, and sometimes their ideas are adopted, right? Nobody knows as much as all of us know, right? Secondly, nobody, and this is a bizarre thing. For all the education, all the experience, and all the knowledge, nobody knows the process better than the person who does it every day. They may not understand the mechanical reasons, the chemical reasons, the electrical reasons, but they know what they got to do to make it work. So it's useful to gain their understanding of the process. All right. So with that said, we're really starting to explore this idea that Y is a function of X. Your excessive cycle time is a function of your process steps and the inputs into the process. Your defects are a function of the process and the inputs into the process, right? So if we only look at the Y, the problem, that is reactive. What we're trying to do is push our understanding to the other side of the equation. What is the process? What are the inputs of the process that are causing that problem? That's what we're doing in brainstorming. We're trying to get a list of all these things that can cause that problem. Everybody good? And so lots of techniques for this. We're going to talk about two in terms of knowledge capture. That's the affinity diagram and the fishbone diagram. All right. They both are good tools, and I wouldn't say one is better than the other. They just have different angles, different ways of attack. The affinity analysis is not very structured, but it's very quick. Basically what you do is you give everybody on the team a stack of Post-it notes, and you may limit it. Give everybody 5 Post-it notes, Sherry. Maybe you give them a whole stack. I don't know. But give your people on your team 5 Post-it notes, and then tell them one idea per Post-it note. You can write as many Post-it notes you want, or you may limit it to 5, your choice. But you give them Post-it notes, you say one idea per Post-it notes. Tell me why we have this problem, whatever that problem is. And so what happens is in about 5 minutes, if you got 5 people on your team, and each one of them comes up with 6 Post-it notes, in 5 minutes, you've got 30 Post-it notes on the wall as to why you have this problem. Now, inevitably, there's going to be some duplicates, right? So you take the duplicates, you put them on top of each other. That way you only see the top one, right? Sometimes you have some that are similar but different, but they kind of fit in the same group. That's the idea of affinitizing. We put them in the same general group. The duplicates we put on top of each other, but the ones that fit in the same general category, we put together. Good thing about the affinity analysis, it is very quick. Bad thing is it's not very exhaustive, right? The good thing is it's not as susceptible to groupthink, because you're writing your own ideas on a Post-it note by yourself. But the bad thing is you don't bounce ideas off of each other either. So it's like, like everything. It's good things about it and bad things about it, right? Here's an example. Did a brainstorming with people who work in a restaurant, right? Specifically a drive-through restaurant. You say, why are people aggravated when they eat at our restaurant? And they started throwing out ideas. Well, we forgot to give them their ketchup or their mustard, or we gave them somebody else's order, or we couldn't understand them and we had to ask them 6 times what they said, or we gave them the wrong change, or all these different reasons. But you notice they threw out the ideas, then they kind of put them into groups. And all these are around peripherals: straws, change, napkins, condiments. This is around the actual food. We prepped the food wrong. We gave them the wrong food. We gave them somebody else's food, right? Or this is around communication issues. So that's the idea of affinitizing. Once you get all ideas, you kind of put them into general groupings. There's no right or wrong way to do this, right? But it generally is done one idea per Post-it note. That way you can move them around. But with a team, you can do this and get a lot of ideas real quick. The disadvantage is it's not very exhaustive. It's not very thorough, right? It's quick. Okay. That leads us to the second idea of a fishbone diagram. All right. Everybody I don't think we did this last week. Everybody got a pencil. Everybody got a pencil, and everybody's got a spare piece of paper. Everybody good? All right. You got 1 minute. Everybody got 1 minute. I want you to write down every bird you can think of. You guys ready? Go. Write down every bird you can think of. Go. And just so you know, there's 10,000 species of birds. So we're going to get a big list here, I'm sure. Thirty seconds left. All right, everybody stop. Count how many birds you got. And what I'm going to do is a frequency plot. Right? So let's just start it off. I'm assuming everybody that's online is actually online, so I'll ask you guys. Patrice, how many did you get?
8.
How many?
8.
8. Cool.
Yeah.
Andy, what'd you get? Guys, go ahead and unmute. Everybody unmute.
16.
15 or 16?
16.
16, right? Nanali, how'd you get?
9.
9. And let's see, Rena?
23.
Dude, really?
Wow.
Plus over here. Okay. Show off. Hey, son?
I got 4.
Yeah, I'm with you. I'm like turkey, duck, chicken, turkey. Nope, said turkey. I'm not good at this sort of thing. Sherry, how'd you do?
I got 7.
7. Good. Carlos?
16.
16. Mr. Thomas?
Got 5.
Yeah, again, I'm with you, but I know. Let's see, Natalia.
4.
We're in the same bucket. Catherine, how'd you do?
12.
Hamaya?
17.
17. Show off. And Gotham?
7.
All right, 7. You know what the problem is? And for us, for you and I, that's mere mortals. We're down here, we'll ignore that, right? For us down here that are mortals, you know what happens? You run out of ideas real quick because you brainstorm, you got out. This happens with teams. This happens with affinity analysis. You brainstorm real quick. But what would have happened if I said, think of all the birds of prey that you can think of? Would that have helped you think of other birds? You start thinking falcons, hawks, eagles, right? Or I said, think of all the songbirds. Or we could say, think of all the flightless birds. Anybody think of flightless birds? Maybe we could really break out of this systematic thing and say, think of all the sports teams that are named after birds. Nobody ever thinks of Seahawks and Orioles and Cardinals until you do that. And you're like, oh, yeah, right? Okay, or Falcons even. But the idea here is if we did channels like, okay, take the first 15 seconds, list all the bird of prey. Take the next 15 seconds, think of all the flightless birds like ostriches and emus and roadrunners. And even if they're not flightless, it doesn't matter. Just get them up there, right? Penguins. Maybe we do the next 15 seconds for songbirds, right? And the last 15 seconds for sport teams. We'd have got a better list than if we had just said, think of all the birds you can think of. You guys follow the idea? Guys, that's what a fishbone diagram is. A fishbone diagram, instead of just saying, list all the reasons why we have this problem, instead it says, all right, let's specifically ask, what are things that the human could do to cause this problem? What are things that could be wrong with our method to cause this problem? You guys, you see the distinction, as opposed to just asking for a bunch of ideas. Now we say, okay, what could go wrong with the machine that could cause this problem? What could go wrong in the environment to cause this problem? Lighting, temperature, humidity, right? Could our measurement systems be causing this problem because we don't measure things consistently? I don't know. But that's the idea behind a fishbone diagram. Now, you know what a common error, I would be willing to bet most people here have done a fishbone at least once, or you've been exposed to it, right? The common error with fishbones, Natalia, is that people will say, All right, give me an idea. And they'll say, I think it's because we're not doing our PMs. All right, is that a methods issue or is that a people issue? And people, that's not the best way to do a fishbone. The best way to do a fishbone is say, all right, team, let's just focus on the environment. What could go wrong with the environment to cause that problem? And then it doesn't matter what they say, put it on, it doesn't matter which category it goes into. All right, is a penguin a flightless bird or a waterfowl? Yeah, it's both. Who cares? The goal is to get the word penguin up there, not to figure out which category it fits into. You understand the distinction? And that's why people get wrapped up in this. They try to figure out, it doesn't matter what category you get it into, really. The goal is to get it up there. But if we go leg by leg, right, here's a really interesting thing. And I'll throw this out at you too, just for fun, because I've used the fishbone like this, totally different situation, but similar in outcome. Let me switch over to the other camera. Oh. Yeah. Sometimes you have a process that used to be running good, and then now it's not running good. When you've got that situation, Rena, something changed right there, right? So what, and some people are like, what changed? I don't know what changed, but you know what we could do is if you get the right people in the room, you could build a fishbone diagram and you could say, well, we've got our change right here. That's our change. Did we have any change in personnel? Did we have any change in raw material? Did we have any change in the environment? Did we move it to a different part of the factory or a different part of the office or to a different location inside the lab? Did we change our method? Did we change our measurement system? Did we change out machinery? Right? So it's interesting that you could say, what happened here? I don't know. Right? Let's just ask questions. Did we change any of those 6 categories? Do them one at a time. Sometimes you can actually find what happened. We did this one time at a refinery I was working in. They discovered that they had done a PM. They forgot to close the valve. They forgot to reopen a valve they had closed. It was in a water treatment plant. That one simple oversight was costing about $90,000 a month in carbon canisters. And when we finally discovered it about 9 months later, they went and opened the valve back up and the problem went away. So it's like literally a valve was opened or closed. And you sometimes see very simple things like that causing very complex problems. Other times, Patrice, you have very extraordinarily difficult things causing even more difficult problems, right? So it just depends on the nature of problem solving and what you're dealing with. But a fishbone diagram, that's the whole point, is to, instead of just saying, what are all things that can cause the problem, we narrow down to a channel. It's called a channeling tool. We will channel down those ideas. And you'll see this again later on in a different application, all right? So remember, all we're trying to do is get a list of all possible root causes, even if they're silly, even if they're improbable, even if some people say, oh, big bird, or they'll try to play Woody Woodpecker, that's a type of bird. And okay, put it up there. It doesn't matter because it may cause somebody to say, oh yeah, woodpecker. I didn't even think about that, right? And you actually get a real one out. Or they see a big bird. What is big bird supposed to be? I have no idea. He's big. That's what he's supposed to be, a big bird. But I don't know if it's supposed to be an actual type of bird. I don't know. My wife told me to quit acting like a flamingo, so I had to put my foot down. See, that is a lame joke. Okay, nobody's getting it. Right. Okay, so the idea of multi-voting is you get all these ideas up. I thank you, Hassan, for the pity smile. Anyway, I appreciate it. I thought it was a pretty good joke. I told her she was painting her eyebrows on too high, and she just looked surprised. They don't get any better, not. And Natalia's like, really? All right, sorry. That's as good as it gets. But if you get all these ideas on the board and you've done that fishbone diagram, even if you let people do silly ideas, which is fine, you've got to prioritize them at some point and screen out the ones that don't make sense. One way to do that is using sticky dots. And I prefer to do this all publicly. I like to do it on a whiteboard or do it on a flip chart. But get people to give you the ideas and then say, okay, everybody on the team gets 3 votes. Go pick out on the board the top 3 reasons why you have this problem. And you can't vote for your own idea unless you really are sure that's the cause. Don't vote for your idea just to get votes. Who cares who put it up there? At this point, we don't know who put what up, hopefully, right? And so you can go from a whole bunch of root causes down to a prioritized list real quick. So it's interesting, in a single team meeting, you can start with nothing. You could do a fishbone diagram and prioritize, and you walk out of the team meeting with the top 6 reasons why the team thinks this problem is occurring. This has been my experience. If you do a fishbone with the team, almost every time the actual root cause is on that list. And if you prioritize it, most of the time they've got the prioritized root cause on the list. So it's just interesting if you get the right people in the room, get them talking about it, and then give them a mechanism to collaborate. You can actually get some ideas that are useful and help you drive in the right direction. Everybody okay with the idea? All right. So with that said, and this is just that prioritized list that came out of it. We are at 147. We will have to expedite this exercise, but I do want to do the exercise. All right. I want you to think about you've gone out to your car, or better yet, your friend called you on the phone and said, Sherry, the car battery is dead. The lights won't come on. When I turn the key, nothing happens. I got a dead car battery. And instead of saying, I'll come pick you up, you say, well, let's brainstorm as to why you have a dead car battery. And they're like, will you come pick me up later? Yeah, I'll come pick you up later. But first, I want to brainstorm. So you're going to work with your team to come up with what are the things that could cause a dead car battery. All right, we're going to do no more than about 7 minutes. You got to be lickety split fast, right? So let's just pick 2 or 3 categories that you think are important, right? So we could do personnel. Let's all do the same ones. Let's do personnel. Let's do environment, and let's do the machine. So the machine is the car. The environment is the environment, and you've got personnel. That's the human being that's driving the car. Come up with at least 2 reasons on each one of those legs that could be causing the problem. All right, I'm going to screenshot this just to help you remember. And we're going to do just make a note. We're just going to do environment, machines, and personnel. Everybody good? And I'll do 7 minutes. When you come back, I'd like you to come up with the number 1 reason based on your brainstorming that you think you've got a dead car battery, right? There is no right answer because we don't know. But what I would like you to do is at least have the opportunity to work through this. Now, when it comes time to working with your team, you'll be doing this actually with your team. So I'm going to drop and find it. There's the chat. Chat. And so you should get that screenshot there in your chat. You guys see that? All right. You can use that. You can do it. There's actually a fishbone diagram template, which is just an Excel template you could fill out if you wanted to do it that way. But in either case, 7 minutes with your team. Come back. We'll do a quick debrief. We'll be done by 2. So let's just do 4 breakout rooms. Rooms are open. I'll see you back in 7 minutes. Just a few seconds and everybody be back in and we'll debrief. All right. One of the challenges of doing this exercise is that people have differing levels of understanding of how automobiles work, right? The other thing that's difficult in dealing with this is maybe you've never experienced a dead car battery. So this is completely foreign in your experience, right? Now, this first will probably be reasonable when you're working with a team. They may never have experienced that particular problem, or they may not have as much understanding about the problem. But even so, by having a good team, a diverse group of people who have some knowledge of the process, you should be able to get some reasonable information, right? If you get the people who do the process every day, you get a couple of subject matter experts, usually you can get some really good brainstorming here, even if you don't have a clue what the process does, right? And so I've been in that situation too. Before you do brainstorming, go to Gemba, go see it yourself, make sure you get some ideas. All right, real quick. Andy, Carlos, and Patrice, what did you guys say was the most likely reason why you got a dead car battery? What'd you have?
I think we agreed that just the person left their lights on or left it running.
Okay, they left something going and it eventually drained the battery. All right, how about Nalali, Natalia, and Reno? What did you guys say? Most likely reason?
We also landed on like somebody just leaving the lights on. And actually, I have to give credit to Natalia because she said if we looked at this from the perspective of an electric car, it could be someone failing to charge it or to actually plug it in.
Well, it could be in a regular car, an internal combustion engine, because there's a charging circuit to recharge the battery after you drain it every time. Room 3, which was Mr. Thomas, Mr. Morales, and Miss Wyatt. What'd you guys say? Most likely reason?
Yeah, we have leaving the lights on overnight.
Interesting. Okay, leaving the lights on. And room 4, which is Gotham, Catherine, and Sherry. What'd you guys say?
We had those as well, but also if the car's in drive, you probably like it needs to be in park.
Okay. Guys, if you go back to 1964, if you left your lights on, good luck, right? It was going to drain the battery and you didn't know it. You move into the late 60s, early 70s, and even into the 80s, they put in mechanisms that would buzz at you or ding at you and say, hey, you left your lights on, right? What do modern cars do? They turn the lights off for you
automatically.
After like 5 minutes or so, it'll turn the lights off. Very handy, very helpful, and helps prevent the issue. In my experience personally, you know what the number one reason for dead car batteries is? The battery's just too old. It's just outlived its usefulness, and he's got to go get a new one. You move to like upstate New York. You know what a big cause of dead batteries is? It's just so cold. You can't get enough power to come out of the battery to start the car. It could be, guys, it could be a myriad of reasons. And sometimes it's so specialized, you got to know what's going on. You got to start diagnosing, and there's a little bit more to it, right? But you guys get the idea behind fishbone diagrams. You're drawing on the knowledge of the team. It's important to make sure you have people on the team who know the process is being worked, right? And that was part of our discussion we had early on. All right, we're at the end. I'm going to stop here. So I will watch for the announcements. I'll be posting the video this weekend. I'll also post an invite for not this coming Tuesday, but the next Tuesday, October the 8th and 9th for coaching. Again, voluntary if you'd like it, but if you want, you'll need to sign up on that. Any questions you have for me, send it. I try to do the grading in an updated fashion. I think I can't do the grading until class today, so I'll get that done this weekend. Anything comes up, let me know. And I will let you go. Thank you for your time, and I will see you all next week. I'll stick around if anybody has questions. Ciao. Have a great weekend.
Thank you.
Thanks, Jim.
Thank you.
Thank you.